Good evening, everyone. Back for another Chit Chat show. We are joined by, who are we joined by? Toady, Pete Shea, and George Netanuk. Nice to meet you all, and nice to have you all on this stream. How are you all doing?
Just had some corn on the cob. Con is eyeing that he wants to have some. He loves to eat the corn cobs.
George, do you think we could see? Do you think we could see the doggy?
Oh yeah, hang on a second. Just trying to get the live stream up here.
Yeah, there's someone that did running there.
Do you whip out your corn on the cob a lot, George?
Say what, Pete?
I said, do you whip out your corn on the cob a lot?
Oh, come on, Pete.
Go ahead.
Okay, let's see. Hey, Con. Just a minute. Okay. Tip the camera down here for you.
Hey, there he is.
Oh, how lovely.
There, Con.
How old is he?
9.5. Want some corn? Huh? Here. He loves melted butter and salt that I have in the tray here. Okay, here. Come on, shoo.
Is he a globe earther, George? You reckon? You think he realized that the Earth is spinning at 1,000 miles an hour beneath his feet?
Oh, he's a very.
And he goes for that frisbee.
Yeah.
He's probably Coriolis built into him, right?
I'm just amazed that he eats corn in the cob. I've never seen a dog eat vegetables like that. It's terrible.
He loves tomato-based dishes like spaghetti and anything tomato-based. He just goes absolutely nuts for.
It's got good taste, George.
The one thing I had trouble with him earlier this spring, I found out he loved asparagus. My asparagus was coming up, and I went out to pick out the shoots, and they're all chunked down to the ground.
George, let me ask you, do you think there's any significance in God and dog being the same word spelled backwards? Now, we know that the dog is the man's best friend, and, well, of course, God will supersede that, right? Do you think it's just random? That's what I mean. Do you think it's all random?
I have no comment on that, Pete.
Any greater significance in these sounds that we chose for these greater concepts?
Do you kiss the dog there, George?
Did I what?
Do you kiss your dog?
Kiss him?
Do you kiss him?
As Kiss?
Yeah. Do you give him a kiss?
No, he kisses me. He licks me. I shouldn't say he kisses me. He he loves. A lot of dogs do. They love the taste of human skin because you have salty skin. They like to lick that.
Cats do that too.
A lot of our bodily fluids are salty, actually, which brings up an interesting topic maybe that we can get onto later on, which is the nature of clouds themselves. We're told they're just water particulation, right, which formulate into a certain series of patterns for some reason or other. But, excellent to have. Dogs know more than what we know, right? And dogs are man's best friend for very certain reasons, right? And I would say that the words are chosen very, very specifically. And if we look at the letters that are chosen to represent these greater concepts or ideas, then we can, I guess, progress in our understanding somewhat. Let me just say before the start of this conversation that, of course, flat earthers and ball earthers are on completely different and diverging pathways on pretty much everything beyond a certain point.
Pete, on your waters above and their saltiness, I've never noticed, as I think I've mentioned to you before, when I've been in fog, where obviously the clouds have come down to my level, when I'm up on, I don't know, Bodmin Moor or somewhere, I haven't noticed them tasting salty myself. I don't know about you, maybe you have, but I haven't. Anyone else on the panel notice clouds tasting salty?
Do your bodily fluids? You can appreciate that our bodily fluids, a lot of them have a salt characteristic to them, right? Salty tears, urine is salty, semen is salty, blood is salty, right?
Agreed.
So this is an all sort of encompassing thing. So would you know what to look out for? When you think of salt, you think about dipping your finger into a jar of salt and tasting it, and you should get some sort of a similar effect. Just like the ether, that is something that's ever present, we would just not consider it. So that would be my answer to that. Vaguely, anyway.
Oh, I don't find that very credible, sorry.
That's
I can
okay.
taste salt, in liquids, even a small amount of salt. It's pretty noticeable. Can't taste it in clouds.
You want more? Huh? You want more?
You can't taste salt in clouds, all right.
What is George do? What are you doing, George? A square dance or something?
Hey there, Colin. Say hello to the camera. Huh? Come here. Come on, Colin. Say hello to everybody. Oh, God, he's 80 pounds. You there? Huh? See hello to the camera? Okay. All right. Oh, no. Come here. All right, you want the dish? Come here. Okay.
George, let's just kick this off, and let me comment briefly on what you were talking about in your extremely long and, well, I described it as a sort of a high school or secondary school a lecture in applied mathematics, right? So for all the world, though, bottom line, for all the world, doesn't it appear like the Earth is flat and stationary? Isn't this the first sort of point that we need to take all further reckoning from? This is our appearances. This is our experiences. You did a lot of work there in terms of letters and numbers with the pen and drawings, etc. When it comes down to ascertaining the basis of our reality, we have to think our way through it. And this thought is based and developed based on our experiences as human beings. So will you at least accept that for all the world, that it does seem like the Earth is flat and stationary?
I've never denied that.
Excellent.
That if I've always maintained that if you go out at nighttime on the shore of a lake, the ocean, you look up, you see the lights in the sky moving east to west, all you can ascertain is that there's relative motion. You don't know at that point if you are in a stationary platform called the Earth and these lights are moving, or if the lights are stationary or apparently stationary and you're moving from west to east. You can't determine that from that one observation, but we have many more observations that allow us to differentiate which one it is.
So the question is, how do you go about, as the individual thinker? I believe that we're all capable of the same level or manner of thoughts. It just depends on how much work or effort we put into it, right? So as the individual, how do we go about then trying to ascertain, George, which is actually moving? And I'll make this question more specific. At what point in history can you point me to that says, at this point, everything was decided away from prior knowledge and belief and held systems to, the system that we have today?
Pete, I don't think we can say at any one particular point in history mankind had an aha moment. It was kind of more of an evolutionary process. Some people had an aha moment, but mankind as a whole did not. It just took many different types of tests and observations over the last, say, 400 years for us to determine. One of the big, I guess you would say, moments in history would be Galileo, when he got wind of the Dutch having created a telescope, and he got a hold of some lenses and learned how to grind his own lenses, and that he made a better telescope, and he started setting his sights, so to speak, into the heavens, looking at the moons of Jupiter and things. And, that was, I think, kind of the beginning of where we had some very solid information that, it's the Earth actually moving rather than the heavens. And, there's been many tests since then. I mean, many different ways. And of course, now we have modern instrumentation. We've got satellites out in space looking at the Earth. I mean, it's quite undeniable that, the Earth is round and the Earth is rotating and the Earth is moving about the sun.
So,
I mean,
George, question: how good were Galileo's, magnification? How the moons of Jupiter? You say what kind of magnification was he getting?
I don't know what he was getting, but I
Right.
know.
It would have been
I know
rudimentary.
I have a little telescope that I can easily see with 35 power. I can see 7 moons of Jupiter.
But what conclusions would he have come to, George? I mean, you just admitted yourself that it's very reasonable to assume that the Earth is flat and stationary, right? Even though it's been proven otherwise. But what conclusions could he have come to based on that alone? Looking at something pretty vague, you'd imagine, the moons of Jupiter through a rudimentary, basic telescope. You know, I can't see how that would be a turning point. That's my point.
Yeah, I mean, he was able to watch the nightly dance of the moons of Jupiter changing relative positions and stuff. And with Kepler's laws, he was able to confirm that, the third law of Kepler, which is the of elliptical orbits, that the semi-major axis squared divided by the period of rotation, or cubed. I mean, the semi-major axis cubed divided by the period of rotation squared is equal to a constant. And he was able to determine that for each of the moons, and infer from that and saying, well, why should we be unique? I mean, looking at Jupiter, looking at Venus, looking at Mars, seeing the phases of Venus, phases of Mars, you can infer.
Why shouldn't we? Why shouldn't we be unique?
Maybe things are rotating and moving.
Are you unique, George? Is your dog Can there unique? Why shouldn't we be unique?
Why should we?
Well, it's a question.
Again, this comes down to what I was talking about earlier. Nature likes to be considered.
George?
Well, the way physics in the world works. I mean, the way that the world works, the way forces interact, the way.
Where did all the Earth's oceans come from in light of all the vast emptiness of space? Which developed first, the water itself or the component parts, the hydrogen or the oxygen?
I imagine it was a component part, but I'm not an expert on geophysical sciences of the Earth.
Yeah.
I'm not a geologist.
But you have to sort of hold, if you hold to a certain idea, a Big Bang, singularity, origin to everything, you have to hold to sort of the official story more or less, right? So you will go along with that, even though you can't sort of relate to it yourself. You don't know it. You will go along with it if it's
well. I mean, I look at the bigger picture. I don't get so caught up in the details as a lot of you want me to. I just kind of look at the bigger picture, being an engineer and working on problems and seeing how these laws work, and they make predictions. And when I go out and make experiments, conduct experiments, design experiments, and I find that the outcomes of these experiments agree with what was predicted by the mathematics and the equations, it makes me feel pretty good.
That's good for you, bud. That's good for you. Excellent. But you have no question. So do you think all flat earthers are retarded? Now, you've been in this arena pretty much going over the same things you've been going over from the start, which is about, as far as I remember, about 3 years you came on Earth Discussions, right? And you were doing your frozen lake experiment.
Yeah, about that. Yeah, I've been on the scene maybe about 2.5 years. Yeah, somewhere in there.
So do you think all flat earthers, especially long-term flat earthers, are insane at this stage? It has to be an insanity on someone's behalf, doesn't it, George? It really does, I think.
Well, I think they're highly misguided. It's a silly concept and ridiculous, given modern instrumentation and the overall.
You just said it was reasonable to think that the Earth was flat and stationary a few minutes ago, George.
Say what?
You just said a few minutes ago that it was very reasonable to think that the Earth may be flat and stationary. And now you say it's a ridiculous concept.
Reasonable with just that one data point. That if you're on the shore of a lake and looking up at nighttime at the heavens, if that's the only data point you had, yeah, it would you'd have to question which one is.
Well, the data point from every one of us being on Earth that we've
but
never
I'm saying there's
experienced any movement
overwhelming
beneath
evidence.
us.
There's other evidence besides that. So
Sure.
at this point, I have to say it's silly and ridiculous.
Well, that's fair enough. You sort of contradict yourself a little bit, and I guess
No,
one
I
man.
didn't. I said if all you had is that one data point, you would not know which it is. But we have many, many other observations and data points that allow us to determine what the right answer is.
Okay, I heard you, and you answered that question that I asked before you said that, George. But that's okay. But look, there seems to be some sort of miscommunication going on. I mean, who do you hope to influence in terms of these?
I don't hope to influence anyone. All I'm doing is I'm kind of winding down here with a lot of this stuff, and I just thought I would try to get some facts out there, get people to understand some of these concepts, so maybe the people on both sides can come to a little more reasonable discussion rather than using all these misconceptions that are out there and the wrong physics. I'm not going to sit here and try to influence anybody. I'm just putting it out there. If you think it's reasonable, if you want to learn from my experience, and then fine. If you don't, well, so be it.
Are you concerned you might be corrupting innocence or corrupting truth in any way?
No, not whatsoever. No.
You sure?
Yeah.
I'll go on camera in a second, man. But when it comes to Coriolis that you were talking about earlier on, well, going north to south makes a massive difference, George. And now we have the ability to, like, say, drone technology, sort of get up above a situation and look down on it. So if someone was at, let's say, a military missile was being fired from one place to another, north to south, right, at 1,000 miles an hour, and you had the drone footage looking down on the target, the firing position, and the whole trajectory itself. Now, are you telling me, depending on, remember, we're looking at it from the drone footage, not on ground level, are you saying depending on the speed of the missile, that the heading would have to be varied as it traveled through these different, what would you call them, speed zones, I guess, where the Earth quickens up?
Yes, I do. Yes, it would have to be.
But you know what I think you'd see, George, as you zoom up? You'd see a direct line between the missile firing position and the target itself, no matter what the distance, if you had the ability to look down.
That's right. Well, the corrections are ever so slight, so it's going to look like it's taking a straight path. Like I told you, is once you add the tangential velocity to the initial velocity towards the heading, you get a straight line path that isn't in the line of sight where you see the target to begin with. It leads the target a little bit because of the tangential velocity, but if you're in flight long enough, you have to even make more corrections, but those corrections are ever so slight, like I talked about with the jet going at 530 miles an hour from Glasgow to Plymouth. All you have to do is correct 0.2 degrees every minute. That's negligible. What if the missile you have to wait a lot longer before you made any corrections, because there'd probably be more slop and hysteresis in your steering mechanism or in your of the plane. There's never perfect mechanical interactions with gears. You always have dead zones and things like that. That's why you have some slop in the steering wheel of your car. It's not infinite resolution on these things. So you'd probably have to wait even more than minutes to make your correction.
You're saying it's so slight, but what if the missile speed was halved? Wouldn't you not have to vary the heading?
You'd have to do more. Yeah, the slower you are, or it's actually turns out it's basically time in flight, is it not? Because the longer you are in time in flight, the more time the Earth has to deflect from west to east, to move from west to east from underneath you, right?
So let's just say you agree intercontinental ballistic missiles are a reality, right?
Of
So
course, yeah.
let's say that a war between North and South broke out. So someone was launching, let's say Canada were launching a missile down to South America somewhere. So they would have to literally, I know this sounds ridiculous, but you're going to have to agree with this, right? They're going to have to aim at a point at the particular moment that they press the red button to take off at a point, let's say, that Hawaii is at, and wait for South America or Middle America to catch up to the missile. It'll be an interception course, as opposed to what I know happens, George, is they just hit the same coordinate buttons and they press the red button then, and that's it.
You're absolutely sure about that, are you?
I'm absolutely certain about that on a flat and a stationary.
Well, what about flight computers? Don't you think it computes the coordinates?
What about a bullet, George? What about a bullet?
Huh?
What about a bullet? A missile is pretty much a bullet, right? If you have a target, you aim for it. Now, you can take different variations or different influences into account.
I'm saying, I told you that the bullet will miss its target if you don't make allowances, if you don't lead the target.
Absolutely. That's because the bullet is a projectile, George. You know that.
So George, on your target, on your diagram, did you exaggerate the amount it moved? Because it did appear to move a lot, I thought. Would it actually have moved that much, or were you just exaggerating how much that moved? Do you know when you drew your dots and you said, here's the bullet, here's the target, here's the bullet?
Exaggerated so that you can see it. Yeah.
Okay. How much would it be?
I'm just trying to illustrate it. I mean, if I were to draw the actual deflections, the width of the marker would more than swamp out the actual deviations,
So the figure I was given, George, was I think something like at 4 kilometers, it might be a foot they have to correct for. Is that the kind of order that we're talking about?
Well, it depends on your latitude.
For a sniper. Okay. All right. Okay.
Because remember, if you're sitting here, the greatest Coriolis that you're going to have is at the pole, shooting from the pole. Because think about this for a minute. Suppose you're at the pole and you go out 50 miles, and this is where you position yourself, okay? Now remember, the tangential velocity is omega r. Omega is constant for everybody. That's the angular velocity. So the tangential velocity changes in direct proportion to the distance out from the pole. So let's say we're 50 miles to begin with, okay? And let's say we have a target out at 150 miles. That's 3 times further, right? So the tangential velocity starting here, if we have a tangential velocity, say VT1, the tangential velocity here is going to be 3 times this value because the R is 3 times the value. So this is going to be 3 times VT1, a huge difference in tangential velocity. So you're going to have a great deviation going from 50 to 150 miles when you're up near the pole, but you get down towards the equator. Now you're at, remember, the distance going out to the equator is 3,959 miles. Now, let's say we start out here at 3,800 miles. Now, we're going to shoot the same distance, another 100 miles. So we're going to go to 3,950 miles. So what's the difference in tangential velocity? A very little difference, because VT1 here is just this distance times omega. And what's the VT2 in relationship to VT1? It's just the ratio of these two, 3950 to 3850. There's hardly any difference at all. It's that ratio.
Okay, so quick question on that then, just a very quick question, sort of trying to move away from the maths a bit. Then how do the military and other people account for this? Because it looks quite complicated. It looks very important to know actually where you are on the Earth.
It's not very complicated. I mean, they have computers to do these, and before they had the laptop computers and things like that, they had tables. They have books with tables that, given your latitude, what the correction factors were. Latitude, you can imagine you had a table that told you on this scale we have latitude, theta L, and then we have distance to target, say. So you have this whole grid. Given different thetas, given different distances to targets, it'll tell you what the corrections are.
So when the Germans had that big gun and they were firing, they had that huge sort of bullet gun. Yeah, they were trying to fire it across the channel at the UK. Those corrections must have been quite significant then.
Yeah, they had to aim it at Ireland first, right?
Well, up as well, because it had to go over the bulge, didn't it? Yeah.
George, can you clear off all the letters there and just draw a circle again for the Earth and the North Pole center, and we're looking down on the Earth, right? Just getting back to the sort of macro point I was making, that'd be cool. You have the gun firing a missile at 1,000 miles per hour. Let's just keep it nice and round from the North center, aiming at Mexico, or a bit further south, somewhere on the equator, close enough to the equator. So we understand. This according to your, so you have to explain this. So anywhere along the circle, you can just draw a dot as well along the circumference.
So you want to be on the perimeter at the equator?
Yeah. So let's say Mexico, so southern Mexico,
okay,
somewhere
that's where
there.
you are. All right.
Yeah. Zoom out a small bit there, George, because the people can't see the top of the circle. You cut off the head of it.
Hang on. Get my Skype on here and see. You can't see this. It's showing on my camera.
Well, no, it's well, maybe it's fine then. I just can't see it. Maybe if you just move Mexico over to the 3 o'clock position, just for me here, then that'd be better. It doesn't matter. It's the same thing. It's the same thing. So, right. So we'll say that the distance is, just for the sake of pig iron, 6,000 miles down along the curve of the Earth from the North Center to Mexico, the target that you want to blow the shit out of from the North Center.
To do these computations, Pete, remember, we have to do our distances with respect to the axis. So if you're down on the equator, the R value is the radius of the Earth. So this value here is through the center of the Earth to the equator. So this is 3,959 miles, say.
Right. So, excellent. So we can just round that off to 4,000. Just keep it nice and simple.
Sure. Okay.
So the missile, we know, travels at a maximum of 1,000 miles an hour. We want to blow the shit out of Mexico. We're going to set a heading, right? And we understand that at 1,000 miles an hour, it will take 4 hours to get to Mexico. Now, that can be brought into discussion because obviously, if everything is turning, it's going to take a little bit longer than that, and it has to travel further. But where do we point, George? Where do we point when we want to take this shot? We want to hit our target.
Okay. Well, first thing is our mega is roughly 72 times 10 to the minus 6 radians per second. Okay? That's our omega for the Earth. So, are we going to shoot from the pole? Yeah. You want to shoot from the pole?
You want to shoot at Mexico. Now, I know that Mexico...
From where?
From where?
Mexico, or somewhere along? Huh?
Yeah. You want to point to from the pole to Mexico.
It makes a difference. Where are you shooting from?
Well, from the North Center, the very center of the North Pole.
That's what I asked you. You want to shoot from the pole.
Exactly, yeah. I said that.
Okay. So you're shooting from the pole.
Right.
All right.
Missile is 4,000 miles an hour. So how far do we have to compensate east or west?
So our velocity is 1,000 miles per hour. So the trip time is 4 hours. Okay. Now, let me grab my calculator.
Mexico will have moved 1/6 of the circumference of the Earth.
That's what I was just thinking. It'll be a 6.
Okay.
Right, Pete, it'll have moved to 6.
Yeah.
We got to
take divide the Earth, that pie into 6 portions.
60 degrees it'll have moved.
1/6.
Yeah. 4 hours times 15 degrees per minute is 60.
You need a calculator for that, George. I was having a joint at the window.
It's going to end up there.
As Tony did.
Yeah, in 4 hours you're going to end up there. You're at a 60 degree. Okay. Because the Earth is turning 15 degrees per hour. It's 4 hours, so now, 60 degrees. Okay.
You've divided that. You've divided that into 6.
Get it. you're going to have to shoot that way.
Right. So if you now calculate just roughly, George, you see where that new line of reckoning intersects the circumference. If you calculate roughly the distance between that point, the new point on the circumference, compared to point P. So along that arc, exactly. What roughly is that? That's easy enough, George. 25,000 divided by 6, right? Roughly. That's about 6,000 miles.
Right.
So when you're shooting from the North Center, you have to aim at a point 6,000 miles to the west of the target point, which is Mexico. Right. Does this sound reasonable to you, George? Or you just point at the fucking thing and let go?
No, you have to lead it. Just like a hunter has to lead a deer that's running through the field.
If I point now to Australia, isn't it at a fixed position to me, George? No matter on a sphere or a flat Earth.
If what about Australia?
If I point to Australia, if I point right now to you, George, and I had the ability to go up in my rocket boots and just follow my finger, I'm going to reach you by honing in on a certain point. You know what I mean?
Well, see, the thing you have to understand, this isn't like shooting targets with slingshots. I mean, when you start going long distances on the Earth, you have to do some flight computations on these things for ballistic flight. I mean, they had flight computers for these things. You put in your coordinates, latitude, longitude, and it does. It gets you a firing solution.
How did Charles Lindbergh or Amelia Earhart cope with all of these considerations, George? Considering they were in fucking flying tin can.
They're flying slow enough that the corrections that you make are ever so slight. I mean, look at their flight times. If you're in flight for 10 hours, it's easy to scrub off a couple hundred miles of deflection or whatever over 10 hours.
You know, Lindenberg was the first person to use a gyro compass, I believe. I think they actually invented it at the airfield where he worked so that he could use that.
See, what you forget, these things don't occur instantaneously. Like if you're in a private jet or a private plane, Cessna 180 flies with a conversion, flies at about 100, 160, 170 miles an hour. You can get out of a Cessna 180. Well, you're in flight a long time doing cross-country flights. And I've been on long cross-country flights in private planes. And very seldom do you ever look at the instruments. All you do is you look at your maps and you look at for landmarks, and you just fly towards landmarks along the way.
As if everything was flat and stationary, right, George?
No.
I asked Randy to ask you the last time the question, why can't the Earth be flat and stationary? You went on to how planets form, the origins of the universe. You almost went back to now. If you're mistaken about that, George, could you be mistaken about, or does it follow that you'll necessarily be mistaken about the shape and nature of the Earth?
This is something I'm absolutely 100% confident I am not mistaken on.
I'm absolutely confident that you're absolutely mistaken, either purposefully or otherwise.
Well, I'll tell you what, Pete, if both of us live long enough, within the next 10 years, we'll have the answer.
Man, the answer's already there, George.
Who's right and who's wrong?
The answer's been there all along, bud. We all knew it. We all know it all along. I mean, have you met any flat earthers? So you're very passionate. Toadie's very passionate here as well. Rumpus, all the different characters are very passionate because they've so little return for all the effort, right, over the years. Do you know anyone who genuinely, and you respect for leaving flat earth behind and returning to the ball? Sean G, for instance, you respect him?
I don't know him that much to...
or anybody at all. Do you find it surprising that Channel Q did some early work with Math Powerland, the leading flat earther? Do you find that surprising?
No.
No, not really. Do you remember Barbie McGill?
Yes, I do.
Yeah, well, I worked with her, and she ended up leaving her channel with 3,500 subs, and she now knows that, she was greatly mistaken.
Has anyone gone the other way? Has anyone gone the other way, Pete? Has anyone gone from the ball side to the flat?
absolutely. Every one of us have, for fuck's sake.
Oh,
Come
sorry,
on.
no. I mean with the channel. Sorry, no. I mean, yeah, of course, yeah. I'm not being. Sorry, let me rephrase the question. Yeah.
It's impossible. It's impossible not to become a flat earther when you look into it seriously.
No, come on, Pete. Not impossible.
Come on, man. Come on. It's impossible. And it's impossible to go back. Like I say about Bob Glowbusters, it's impossible to go back.
Well, it might be impossible to go back because you're so vested in this, but, you know.
No, but George, the spinning ball Earth is metaphor, but it's all metaphor. The Big Bang references our arrival into the physical world.
Let's not go down that road of.
Listen, you love your dog, right? You love your dog. There's people in China who will eat your dog as quick as they look at him. You'd find that abhorrent. I might find it abhorrent that you eat pig because I think maybe that's cannibalistic, George, because we share attributes with apes, but we fucking share attribute with pigs. And if you're going to deny it, something wrong with you. So maybe there's a different game going on here. And as I said at the very outset, ball earthers and flat earthers are on different divergent paths. Absolutely. But let me just bring the question back again. Do you know anyone who you've convinced? Have you in all your years, all your efforts, said, well, I'm glad that this person has made the switcheroo back, and that'll do then? Anybody at all?
No, I haven't really paid much attention.
That says it all, bud.
So Pete, I had a long conversation with Dean before he left the Flat Earth, yep, and he was sort of trying to convince me, like you say, that it's diminishing returns and why you're there, Toady, trying to persuade people, whatever, having these conversations. The people who sit on the fence are very few and far between, and most people are polarized, yeah? But my point was, I don't really do it for that. I do it because it's interesting, yeah? It's intellectually stimulating, and you get to meet some nice characters, as you would say. I'm not doing it to try to persuade people, either way, yeah? Because I think people should be able to make their own minds up. There's enough information out there.
So let me ask you. I'll ask you, Toady, the same question I asked Ranty to ask George last time, or I generally ask lots of people, why can't the Earth be flat and stationary, man?
Well, I can tell you why it can't be flat.
Not you, George. Shut up. Okay. Toady.
Why can't it be?
Yeah.
It's not the way that the things that I've looked into appear to evidence it. But, I think there's some good proofs that I've looked at myself because obviously I wanted to be sure, just surveying that I've done pretty much proves it. I'm quite convinced by space or reasonably convinced by space. And then some measurements that you've seen that I've done around Egypt and various other things. So I go along with that. It's a consensus until I see something that convinces me otherwise.
I continue doing what you're doing. You'll continue with this. Have you no questions about that? Have you any questions about anything in general, George? Is there no areas? What's the best offering that any flat earther has? So when you look at the silly idea, sure there must be something to it, because otherwise we're all stupid, right? Well, what's going on? Are we retarded? And if we're retarded, you're more retarded if we're having any dealings with retarded people.
Retarded is a strong word. Retarded is a strong word. It's a bit unfair, really. If you've met anyone who generally is retarded, Pete, it's a bit of an unfair word. Yeah, we could say mentally challenged, or we could say something else. But I think
retarded is fine. But we know what we mean. We're not talking about any individual.
Really, do you have a retarded anyone
in the real sense? Actually, this would be more applicable.
Genuinely retarded, Pete? Have you anyone in your family? Because I've got someone quite close to me who's actually genuinely retarded, and I think it's. I think the word's probably bandied around a bit too much.
Well, I don't know your relation there, but I'm talking in the real sense here. So that would be retarded on someone's behalf, either ours, because we can see the silliness of the whole flat Earth paradigm, or you for continually coming back to try and convince fools or idiots or silly people that their whole way of thinking is crazy. I mean, this is the true sense of retarded. Someone is retarded, man. So you don't have to bring anything personal into it. And a word is a word. Nigger is nigger. Nigger is okay to say, or cunt is okay to say. As long as you don't say it to somebody specifically with any hate or any vengeance attached to it, that changes the whole game completely. Otherwise, all words are what they are. People can't say cunt, but they can say country quite easily, right?
But you like to say that, Pete, but I don't like to bandy that word around, the R word, because I think it's used too much, and I think it's used to put people down who don't deserve to be put down. I think people like Anthony and others are asking Arwin reasonable questions, yourself even, right? Sometimes asking, not always, but sometimes reasonable questions. And so I think just calling someone the R word is unnecessarily putting them down. Yeah,
I
I'd
still
rather say
stand by it,
foolish
man.
or
If you
confused.
take a step back and you look at the situation, someone is retarded. Some grouping here is retarded. And I don't forget about the association that
Look
you
in the
attached to it.
mirror.
I'm not
Look in the
talking about
mirror,
that.
Pete.
Well, I'm just saying anyway. Forget about it anyway. George, you just said yourself there is no return. So why aren't you asking the deeper questions? Why aren't you considering if the Earth might be flat and stationary? And here's a question that I have for flat Earthers as well. As you come to flat Earth, why aren't you considering a singular source, a possible singular source to all of these skylights that we see, which seem to move in unison, right, on a daily basis, on a weekly basis, but there is variations as we go through time. But why is no one considering a singular source? It's a reasonable thing, I should think.
How could there be a single source when we're talking about a radius on the order of 3.75 billion light years, where light years is 9 times 10 to the 15th meters? I mean, why?
George, if I go straight up with my rocket boots that I was going to come over and visit you with, I'll get to about, where am I, 52 degrees. I get to about 52 miles, man. And then I'm hitting no-go areas. The highest point I view in my picture is the Kármán line. This is along the equatorial areas, 60 miles high. We're in the outer barrier that begins low at the north, rises highest at the equatorial areas, and down low at the southern peripherals as well. We are in a broken system. Something dastardly and catastrophic has happened to the Earth. But again, that's a different story. That's my story, because I came to accept that the Earth
that's
is
your
flat.
story, but I'm not buying into it. That's all.
But you buy into stars being, what did you say, thousands of light years away? This is crazy stuff, George.
Well, it's been measured. We have several ways of measuring the distances to these lights in the sky. There's standard candles, there's parallax methods, there's radar ranging, there's triangulation. All of these different methods tell us the same story.
Well, you talked about time earlier on, and it's the basic questions that will confound us. What exactly is time? And of course, originally time was described or defined in relation to the passage of the sun.
I'm not into these philosophical.
Just getting back, the point I was making that it was more related in terms of the passage of the sun.
Philosophy in that, go talk to Steve McRae.
It's not me. Listen, this is an open chit-chat discussion, George. You don't have to necessarily be here, but
don't ask me anything philosophy-based. I'm really
It's not philosophy-based. It's going back to the sun, the nature of the sun itself. If we have defined time in relation to the sun and its passage, then we need to know what the sun is. You're after telling me what other suns are, or you've told me how far they are away. So, I mean, if you're going to say I can't go any further into a particular area when every area is ultimately connected, that's fair enough as well. There's no worries there. But just by that, leaving that little illustration behind there, George, how ridiculous your position is in relation to firing a missile from the North Pole to, you'd have to aim at, if you were aiming for Hawaii, you'd have to aim at Mexico, or sorry, the other way around, and wait for the Earth to come into.
You do know, Pete, that those missiles, those intercontinental ballistic missiles, have corrections on them. Yeah, I know someone who used to make like these very special parts for them, which were tested. You know, they blew 100 of them up, and they only used one part. Yeah, because the failure rates were just so tiny that they wanted very precision things. They've got very sophisticated guidance mechanisms in them. So
I don't believe them anyway. I think that's a load of bollocks as well.
Oh, you don't think
all these countries are in cahoots, man, and there's so much fakery going on. You wouldn't believe
CGI?
it. No, well, there is missiles, there is real armory, right? But when you're talking intercontinental ballistic missiles, that sounds like a load of bollocks. But yeah, at the top levels, all the countries are interconnected, and you have a different overarching force, a different game in play.
So you're telling me
could I just?
But it seems to me that none of you are conspiracy-minded in any sense. You have to sort of adhere to an official story on everything.
Can I ask a question? So, if you aimed a plane directly at, let's say, Venice, right, and you're flying for Venice, and you're auto-correcting every 30 seconds, let's say, for Coriolis, right? So that's what you're doing. You would use more fuel chasing Venice that way than you would do, like Pete said, is if you aimed, let's say, 60 degrees away from Venice and let Venice come to you, because you would be going in the straightest line possible. So you would go. So so all the planes in the world would save probably 10% or 15% on fuel simply by heading in a straight direction.
You're pulling numbers. See.
Forget the numbers. Forget the numbers. Forget the numbers. Forget the numbers.
All equations all you want until you put in real numbers and do the calculations. You really don't know for sure.
George, you'd have to travel in a curve. That's why I said earlier on, you have to take this into account later consideration. Instead of a straight line, you have to travel in a curve down a curve.
Yes, you would.
So
you would.
Andy is right.
Hello, everybody. Can you hear me?
Hello, Brian. Nice
remember,
to see
it's
you.
all fantasy anyway. Nothing to do with spinning balls.
Hey,
how you doing, Brian?
I want to answer.
Hey,
I want to answer Randy.
Hey, Dory. Hello, George.
Can I answer Randy?
Hi, Brian. Good evening.
How are things?
I think, to your point, Pete, I've seen the flight maps that Bob the Science Guy has done, because I think he's a bit of a pilot too, and he's got a flight tracker. And they do seem to go in a curve, yeah, surprisingly. So he's got this lovely triangle, right, between New York, can't remember, somewhere and somewhere else. And he shows that it's a triangle, but of course it's got, I can't remember, 120 degrees inside it or something. Don't know if you've seen that one. It's pretty interesting. And it does
the sky
travel.
is contoured, man. The Earth is flat. George, if the Earth is flat, what's the appropriate coordinate system to be used for a flat plane? Cartesian coordinate system, right? Grid-like coordinate system. Exactly. This is our local ordnance maps are all in Cartesian coordinate system.
Well, I mean, there's any number. You could use polar coordinates too.
Sure, but fundamentally, this is what applies now. When we look at the spherical coordinate system, everything is reversed. It applies to the contour of the sky.
Actually, Pete, if you think about it, for flight on a flat Earth, it would make more sense to use polar coordinates than it would to use Cartesian, because if you want to get, say, from this point to this point, it would make more sense to attach a polar system where all you need is the angle theta from a reference point and the radial distance out, rather than going so far over and so far up.
Well, they don't do that though, George.
Let me just say this, Brian, and then I'll go on mute.
Sorry,
no, you're good, man. You're good. Listen, there's a few different considerations. We're dealing with Earth as is. There is a flat plane here, but there is a contour to the sky as well. And life is nothing like we think it is. And we're coming to these greater realizations. Maybe people like yourself and Toady are great helps, and you look back upon as great heroes, George, helping us to awaken and ask all the proper questions.
Pete,
but otherwise, I'll leave it to you, Brian. I have to go back. No worries, Brian.
I appreciate your concern, but don't worry about me. I'm doing just fine. I'm going to continue doing just fine. You don't have to worry about me going down the wrong path.
No worries. Well, you will be big enough to admit, you'll be humble enough to admit if you are wrong about something you don't know.
Oh, hell yeah. But excellent. I'm saying that's why we're going to have to wait. Pete, that's why we're going to have to wait maybe within the next 10 years, we'll have the ultimate answers. It might be sooner. It might be as little as 5 years.
Well, our star kiss is revealed, man. I'm not going to say any more. Off you go, Brian.
Yeah, I have something just there for George. George, can you hear me?
Yes.
Okay. A flight from London to Lagos, okay? Its nautical mile distance is 3,789.6 miles. The average flight time is 6 hours and 50 minutes. The type of plane that flies, its average flight speed would be 575 miles an hour. Now, if that plane flew at 575 miles an hour for 6 hours and 50 minutes, it would actually travel 3,929 miles. So that's actually 139.4 miles more than it would need to travel. So it actually flies the flights from London to Lagos, London, UK, in the United Kingdom, to Lagos, Nigeria, in a straight north-south direction, actually fly at under their average speed to get to Lagos. Okay? Now, the London rotation speed, in accordance to the globe model, is 654.746 miles. The Lagos rotation speed is 1,033.7138 miles an hour. So there is no way that they could account for Coriolis, George, at those massive supposed rotation speed differences and get to Lagos flying less than their average speed. There is no Coriolis, George. It's over. There is your numbers. You can figure that. You can go and check all that out if you want yourself. There it is. Can't be argued with.
Can I just put my whiteboard on? I'm just going to put my whiteboard on here. So this is what George has said. So what we're going to do is we're going to just imagine now we've got two locations. So we have the place where you set off, let's call it the centre North Pole, and we're heading to, let's just put a target
Do you
here.
want me to work this out, or are you going to give me some numbers, or what?
Are you sharing something, Ranty? I can't see it. Oh yeah, it's on the main one now.
Yeah,
okay.
it's on the main one now. Yeah, so you would set off heading for this direction. That's where you would go, and then you would have to correct all the
I'm
way.
not seeing. Am I supposed to be seeing something? All I see is a empty kitchen where Pete used to be.
Hang on.
You need to look at the feed, George. If you look at the main feed.
Yeah, if you
What,
look
you mean the YouTube feed?
yeah, if you've got that up.
Oh, okay.
So as you set off, this is obviously turning, so it's heading this direction. So it's going to move to this direction.
Wait. I'm trying to understand what you got here. So the center is the North Pole?
Yeah, so the centre's the North Pole. The red line is the flight. And obviously you're aiming to go for 3 o'clock. You're setting off to go for 3 o'clock, so that's where the target is when you set off. But all the time, that target that you're aiming to fly towards is turning with the Earth.
Well,
So what you're doing,
go ahead.
your flight is going to correct these miniature little turns that you do for Coriolis to actually get you to the destination. So you're essentially going to do a curved line. Now, if you added up that distance there that the flight has flown, as opposed to, let's suppose we just set a target for here. So we just set the target for there direct, and we wait for the Earth to turn underneath us and for the target to arrive at its destination. So fuel consumption wise, it would be far better for all the airliners to actually just set a target to this direction rather than do what you said and correct miniaturely all the way around chasing it, because you would end up doing a good percentage more in fuel, distance, etc.
So I think the diagram, a couple of comments quickly, I think the diagram's a little bit exaggerated, that bend, Ranty. I think over those distances it probably wouldn't be quite that pronounced.
The thing that everybody's missing here is number one, no, Ranty, in the flight computers, to set a solution, you know you're going to be somewhere on the Earth and you want to get to somewhere else on the Earth, and all you have to do is figure out where that place is going to be at your arrival time, and you fly what's called a great circle route. That's the shortest distance over a curve. It might look curved on a flat map or whatever, but it's the straight line distance that if you took a plane and intersected the center of the Earth, that's the shortest distance. It's called the Great Circle. That's what they fly. If you look at a globe, let me grab my globe.
That's not what they fly, George.
See, all I'm saying is that this, what I'm presenting again, is I'm just representing what you told us before, that this 60% degree turn, it would make sense to aim for here, but what you said is that when you head for a direction, you plot it in and then you just correct for Coriolis. So this would be the correcting for Coriolis, whereas this would be a straight line.
I'm only seeing your face, Randy. I'm not seeing
It's all right. It's on the watch page. You'll see it on the watch page in a minute.
Oh, okay. I didn't know if I was on.
I'm in Limerick here. Brian is in Waterford. I know. I had my little jet boots on, Brian. I could get up here and I'd follow my finger, because I've been to Waterford, and I know that after a few times I'd hone in on the exact point I could point to. I could even point to a lamppost over here, say, and know if I head in a straight line, no matter what speed, I'm going to hit Brian in Waterford and we'll have a nice pint in the pub and chat. Right? Now, George is telling me that it depends on what speed I do, first of all, because the slower I go, I'll have to head for a completely different place, depending on the relative locations of us, and wait for Brian in his different, more southerly location to intersect with my trajectory. Do you know what I mean? So if I could do it instantaneously, then I'd point in one direction, make it there. If I had to do it half the speed or more slowly, then I have to constantly aim to a point further along that curve. This is ridiculous and stupid nonsense. We shouldn't be talking about this at this stage.
Well, What I just put up forward there a while ago, George completely ignored it. My details from the flights from London to Lagos. London is north, Lagos is south. It's a straight line down. At an average speed, the plane would fly further than Lagos. So it can fly less than average speed to get to Lagos. And I gave him all the numbers, I gave him the rotation data. He just completely ignored it. He's ignoring me.
Hey, look it! I didn't ignore
You're wrong, George. I've disproved your Coriolis there and then with details. You're wrong. You're wrong. It's over. I disproved you last night, and you lost the skull.
And you just heard him saying he was an honest man. He would admit when he was wrong, Brian. Let's see if he will. But he won't ever.
He would not admit. Tody is honest. If Tody was wrong about something, he'd admit it. Because I've been there and I watched him in chat say, "Oh, I'm wrong about that" to somebody. So I know that about Tody. But George, no, he would not.
Well, you get rid of this guy.
He's fine. Brian is good, man. He's my fellow countryman. Get rid of you, George.
Brian,
answer his question, George, then. Deal with his question. Come on.
I will. Post the numbers so I can see them.
Just do it roughly. You can trust that he's telling you the truth, man. It's the chit chat.
Rattled off about 20 different figures. I don't know what he has. Have him post the numbers and I'll look at it. I'm not going to answer a question unless I can understand what the question is.
What he's doing is he's trying to kick the can down the road. If I can share my screen here, I have the numbers there. So, Ranty, is George sharing his screen or can I just share my screen now? Just press on share screen.
Yeah, as soon as you share your screen, you'll just all be automatically sharing when you actually start talking. So, away you go.
Let me know when you can see me.
Yep, can see it.
Okay. Now, George. There it is. There is. No.
Well, hold on.
Yeah, I'm not. Yeah, I'm just showing you. You can leave it up there as long as you need. There's all the details.
I need you to rotate it up. I can't see the stuff below 0.5 there.
Can you see all the stuff now?
Is that the end at 5? If rotation.
Yeah, where the number 5 comes in, that's different. The number 5 comes in. Where it says starts at number 4, right down to where it says the difference is. That difference is the speed of the rotation difference at the end.
Yeah, it's basically all 0.4 there, George.
Wait.
I reckon you should give George 5 minutes to consider Brian and consider his answer as well. That's a fair amount of time to give it.
Yeah, you have to look through it.
I grabbed it. I've got it.
Right, George, take 5 minutes and consider your answer. We've all considered this before, of course, and to every flat earther at this stage, the ball earth, we should realize, is just a mere thought exercise. It's not a reality. So anything to do with a spinning ball earth is not part of reality.
No, leave that back up there, Brian, please, because we're going to give...
Sorry, Randy.
Yeah, what we're going to do, we're going to give George about... Hang on, wait a minute. We're going to give George about 5 minutes to look through this, get it through, he's got all his figures in, and we can just talk about anything else. Just leave
exactly.
those.
We can have a side chat.
Yeah, just leave those figures up. What I'm going to do is I'm going to hopefully grid view it. No. Content view. Right. Well, actually, he can see it anyway, so it should be all right.
And let me just say as well, because George asked him the specific question: was he an honest man? He says, "Was he willing? Is he a humble man?" If he's wrong, George, if you can't answer anything in specific or satisfactorily, I hope you'll come out and say this. This is a very specific instance here.
I mean, earlier somebody asked me about navigation systems of World War II planes. I answered.
Okay, well, let's just deal with this. So
let
take
George,
5 minutes, George, and let's all
let George do that, because I got something interesting I want to just mention.
Where is Lagos?
So hang on.
Where is Lagos?
Lagos is Nigeria, capital of Nigeria.
Yeah, Northern Africa, or sort of a bit more Western Africa, isn't it?
Right. Okay. So mentioned World War II planes. There's a very interesting thing I read about, which you probably heard about, no doubt. Ranty, probably Brian has, and maybe Pete has. This Battle of the Beams. Have you heard about the Knickerbein beams that the Germans used during the Second World War?
I can't say I have, no.
All right. So you guys will be interested in this. A lot of from.
Guys, just we have a claim from Saucy London that says that your figures are wrong there, Brian. Says that the London to Lagos is 2,709 nautical miles.
Well, so, I got these figures off of the internet, so I don't know.
Okay, I'll double check it now for you. Right, you guys carry on. Sorry, you were saying something then. I interrupted
Sure.
you.
I'll carry on.
Well, I check it. Ranty, are you checking it? All right.
Okay. So there's these Knickerbein beams, and basically what they were, I think they were about 21 megahertz things, which basically the Germans had bombers that were flying over the UK. Now, when the bombers went over in the daytime, it's pretty easy to navigate. You can correct your course because of Coriolis and just general navigation. You can kind of spot the city from a map, and you can drop bombs. But of course, in the daytime, you can also be shot down very easily. So the Germans switched to doing nighttime raids. Now, the problem is at nighttime, when the UK is blacked out, it's really quite difficult to find where you want to go and drop your bombs. So what the Germans did is they came up with this quite clever system of these two beams. So they had two beams, and like if you imagine one was a dot, one was a dash, and where the two beams intersected, your plane flies along, and if it's on the dot side, it kind of moves to the right. If it's on the dash side, as you can imagine, it moves to the left. And when the two beams cross, that's exactly where I know Coventry is when you're night bombing Coventry. They all know when they hear the signal, and it's the same on both sides in their two speaker headphones in their ears, and then they drop the bombs, right? Now, these things are fascinating because theoretically the curvature of the Earth should have stopped them going over. Now, there was a big debate about whether these beams could even exist, and the British sort of intelligence service had a look at it and wanted to know whether it was possible or not to, whether this could even exist, this idea, because obviously it was sort of, amazing science to them. In the end, what they did is they actually took a plane up and then found that these did exist. But actually, the scientists said it couldn't possibly exist because of the curvature of the Earth, because of the frequency of the radio. There's no way this could possibly exist. But the guy in the RAF intelligence just decided to go up and kind of see anyway, because he'd noticed that the German bombers were getting very accurate at dropping bombs at night. And he found these signals. And it hasn't really satisfactorily been explained by anyone. There's this theory about whether these kind of frequencies could or couldn't bounce off the ionosphere. But if you haven't looked into the Battle of the Beams, I'd suggest you guys, the photographers, have a look at it, because it's quite.
So hang on. What's your simplest answer then, Toady?
Well, my answer is, and I did look into it quite deeply. I think that probably the height that these towers were, because there was one in the Netherlands, and there was one down in France, right, where the two kind of beams were coming from. I think probably there was some bouncing off the ionosphere. Because basically, as a straight line, there was absolutely no way the 21 megahertz signals, I think it was 21 megahertz, I may have that wrong, but anyway, whatever the frequency was, could possibly get through. And I think
if the Earth is curved, right? If the Earth was curved.
Absolutely. And the scientists in the British Secret Service worked out that, this system couldn't possibly exist. And yet they flew a plane up, and they found the signal.
So basically, what you're saying is, this is another nail in the coffin for a curve.
I'm doing you the favour of talking about it because it is an interesting thing.
You don't have to do me any favours, bud.
Yeah, called this Knickerbein thing. And
nor anybody here any favours, I'm sure.
It's a kind of nagging thing, right? It nags me a bit. I'm sure there is an explanation. I don't think anyone that I've seen has come up with one. The other one, and I'm sure you've heard of this, is how on earth did the original radio signal across the Transatlantic one, the one that, what's he called?
Marconi, I think.
Yeah, Marconi, exactly, the one that Marconi did. Because theoretically, he was up in, I can't remember, Northern America or Alaska somewhere, basically. And he got this signal that was sent from Cornwall. And he got this amazing signal, and he said, oh, yeah, I heard the letter S, right? Now, the letter S is actually, in Morse code, I think, just dash, dash, dash. So it's actually a very easy thing to sort of fantasize that you've heard it. He made these notes of when he heard it, and his guys in Cornwall had instructions to send it every hour between, certain hours. So he knew the signal was being sent. But actually, the day before they sent the signal, all of their radio masts all blew down. So they had to only use kind of temporary ones. So, it's debatable whether he could have done it. Now, apparently, you could maybe get a signal like that you could broadcast that far, that distance, at night time, because the ionosphere isn't sort of noisy. There's not a lot of noise around. But apparently, if it's in the daylight part of the Earth, it's kind of unlikely it would have got through. So, again, it's another one of those very interesting ones, if you've read about it, where they sort of basically say he was either Marconi was lying, or he fantasized it. Or maybe he got it on some weird carrier frequency that went on or something. Because that made him famous, of course. Marconi was famous for that. It launched his business and his company, and then sort of the rest is history. And he did actually manage to transmit that distance again, obviously with Morse code, once you've got bigger aerials and stuff. But it's an interesting debate whether he could have heard that original signal, which is so famous, right? Everyone's obviously heard about it.
Well, what I'd say about that, Tony, is the whole ionosphere thing didn't come in until after
Right,
pretty
yeah.
much straight after Marconi.
Oh, you're absolutely right.
Proved that you
No,
could do
but-
this.
That's right,
But,
and because you're right, because people said you absolutely cannot do that; it's impossible. And then they went and invented the ionosphere, or discovered it, whichever you want to say, to account for it. It's amazing, isn't it, Brian? It is a really interesting thing.
It is. What I don't understand is the world record for distance for I keep saying microwaves. The world record distance for microwave transmission. I think it's 186 miles or something like that, or 150, 168 miles, something like that.
Yeah.
And there's a company that provides this service to people, a communication service with masts or whatever, that have that particular record. I think if ECO are trying to break it or something, but they haven't.
Yeah.
But what I'd have to say is this: how come the moon landing does not have the official record?
Oh, what you mean the distance, the transmission between the moon and the Earth?
That there's two problems. Number one, how come that doesn't have the official record? No, or three problems. Number two, how come Marconi doesn't have the official record? And number three, how did they beam to the moon? And how did they beam back from the moon?
So I know quite a lot about
and
that.
avoid the ionosphere that we supposedly have to deal with all the time.
So let's take it one at a time. We'll go slowly on this because I know a little bit about this. Yeah, I guess the first thing I would say is, well, we've gone further out than the moon in terms of radio waves, right? If you look at Voyager and so forth, before Voyager went out of our universe, we got signals from Voyager. I know some people will believe that or not, but I would think.
I'm going to make one critique, but just before you go on.
Sorry, I was just going to go through 3 points.
I know me and Pete won't be, and Randy, I don't know about Randy, but I'd say me and Pete, I could nearly speak for Pete here, would not be believers in that, in them kinds of distances. But that's all I'm going to say.
He knows that well, Brian. He knows that well. He doesn't believe in himself, sure.
We beg to differ on that. That's fine. Okay.
Yeah.
So then the second piece is I've looked at the power needed for the transmission from the moon and what they were using, and the rig that they used. It was a triangulation of I think 3 different places to pick it up, and they had a huge dish which was something like, I can't remember, 60 meters across in Australia to pick up the signal from the moon. And I've looked at the wattage and everything and worked it out. I did the calculations because we had this on a show the other day, so I still got them somewhere in my notebook here. So that all looked very plausible to me from the moon, right? I don't know why it doesn't have the record, distance, but I suppose it's out of the Earth, and I suppose they're looking for the record on the Earth. And then the Marconi one, I guess, there's been a little bit of debate about that because it was one of the first signals. So this is an interesting area. I know that Ranty did a piece around the signals from, I can't remember where it was, Birmingham down to London. And I know there's this debate about Chorwelton. I mean, I've seen Chorwelton, I've driven past it, right, on the M40 numerous times. So, the curve of the Earth there is explained because obviously there's a repeater dish, right, at Chorwelton on this tower that you can see, and then it repeats the signals. So I think some of these things, one has to look into them quite a bit to really get to the bottom of it.
Are you speaking about the BT towers?
Hang on, can I
let Randy speak about that.
Well, can I just intersect? Brian, I think you've got I've just done the double check on the distances, and they're quite correct. Yeah. Those distances are wrong that you've got in there, so it's a moot.
Yeah, I just checked it 4 different ways, and he's off by 21%. That I can't.
I just checked. I got those distances off
the data
the airline.
is just too skewed and too wrong for me to do anything with.
No, it's not all skewed and wrong, George. Because
it is. You're off by 21%.
What you're forgetting here is that plane flying at that speed for that length of time.
I mean, I'll have to
go. 3,900.
I can't do it right now.
Okay. I understand. Hang on. Randy, just stop George for a second.
Will you listen a minute?
No, George, you're trying to just throw the whole lot out the window and avoid it.
Leave Brian say it, George.
Forget it then.
I've just looked at the numbers myself. I just looked at the numbers myself, and there's 3,000. The number I'm after getting is 3,120 nautical miles. That's what I'm after getting now off a separate airline.
Your data is wrong. I'll have to go through it.
It doesn't make much difference.
I'm not going to do it right now.
It's actually better because the plane flying at the average speed it would fly, it would still be 3,929 miles if it flew for 6 hours and 50 minutes from London to So that actually supports it way better, because that means that it would fly way slower than it would even than would be its average speed just to get to Lagos. So how could it be taking Coriolis into account? literally Saucy London is after absolutely bolstering it even more.
Cementing your point. But let George come back with that.
Hang on, let's just introduce Sleeping Warrior. Sleeping Warrior, you there? Can we do a mic check?
I could answer some of these questions about electromagnetic propagation if you want.
Well, no, I want to ask Toadie a question. As I joined, you were talking about Marconi's transmission across the Atlantic.
Have you heard the rest of what I was talking about before that as well, the Nicobine beams?
No. I literally joined as you were saying.
It's a shame you missed the real gold there. But okay, on to Marconi.
and then our friend from Ireland over here, I'm sorry, I forgot your name. He said they didn't even know about the ionosphere before, or they hadn't even discovered it.
Pete, how you doing?
That's right.
Not Brian.
So my question is, do you not consider the possibility that when they discovered, and I'll put that in brackets, like I would say corrected for, when they discovered the ionosphere, do you not think that that's a very convenient moving of the goalposts, in the sense that, as you correctly point out, this is not possible if the Earth is a sphere? They've got this transmission. They now know that it is possible. I would assert that that is simply a bullshit excuse of moving the goalposts. And I noticed that if you listen back to this hangout, you were talking with a smile on your face at that moment.
Well, we'll go through slowly because there's two things here. Okay, and I'll give you my honest answer. I'm an honest person, as you know.
Hang on, Toadie Riley. You called yourself Toadie Riley after Anthony Riley, right?
Yeah. I changed it, if you remember. Yeah,
I do.
I'm only here because
Toadie now. So we got one Toadie talking to another Toadie.
The only reason I'm talking.
All right.
The only reason I'm here at all is because of Anthony. Right, he wished me up out of the ether. Right, the only reason I'm here is because of Anthony. Okay, but I'm a reasonable person. So two things. I did have a smile on my face because I slightly disbelieve the Marconi transmission, that particular transmission, not his later ones that he did to ships 20 miles and then, Transatlantic later on and stuff in the nighttime. Right, but I disbelieve that original one. I think he was a showman, and I think he kind of convinced himself and his assistant that he heard it. All right, that's why I was smiling. The second piece I have experience of, which is the ionosphere. Now, I've done quite a bit of ham radio in my time. Not a lot, but a bit of it. I've certainly used ham radio sets, and I've done what's called distance multiplying. And you have to actually, in certain conditions, at night time, you can bounce off the ionosphere signals, and you can get them to Russia or somewhere, which I definitely could not do in the daytime.
What is it? What form does the ionosphere
I can if you want, Tony,
hang
I
on,
can answer
Not
this.
yet, George.
Hang on, George.
My whole career has been in RF propagation.
Well, let's just ask Tony, what form did the ionosphere take?
Hang on. Let Toadie finish his point, George. Come on.
So my point is, I have some first.
Are you bouncing it off a physical? Are you bouncing it off some sort of a semi-physical?
We'll let George come in because he's much more.
Just please, you answer it, Toadie, because it's your understanding. You claim that you have direct experience here, and then George, a brief answer will do. Toadie, come on.
Hang on. I've not had an answer. I want an answer to my question. My question is, do you not consider the possibility that they're simply moving the goalposts by adjusting for something that's basically impossible, if the Earth is indeed a sphere?
Again, my answer is, later on they did get signals to go that distance. So they knew that they could get signals to go that distance. Whether the original one Marconi did or not, I don't know about. The signals definitely can go that distance. Obviously, it had to be explained somehow, right? There is an explanation about the ionosphere, and certainly I've bounced signals off that I couldn't do in the daytime. I could do them at night time. So for me, the observations, and lots of people do use the ionosphere, the observations absolutely work. So I've got first-hand experience of not being able to talk to Russia, and then I could, after sort of 6:30 in the evening, I think it was, from Cornwall, talk to Russia. So
the answer to the question that I asked you
is no. I don't think they moved the goalposts. I think they had to explain the effect that Marconi showed, and that's why they then investigated, and obviously then the ionosphere came up. I suggest you actually read a bit about how they deduced that the ionosphere existed and how high up it was. But they didn't just go, "Oh yeah, we'll invent this thing."
So an explanation is good enough for you, right? A bit of maths.
No. I mean,
I can answer this.
This is first-hand experience of.
Riley, it's all metaphor, bud. It's all metaphor. So they know the state of reality. Everything is explained. The lie is explained in terms of the truth.
Can I explain?
So this is what we've got to figure out.
Hang on, Pete. Just let me explain. When I was 16, in a tree in my garden, I got a YAG aerial, and I built this aerial and this antenna for making signals and communicating. And in the daytime, I could not communicate with anybody in Russia. And then in the evenings, when it was dark between here and Russia, I was able sometimes, not always, but sometimes, communicate with people over that distance.
So what's the difference between the daytime and the evening time or
Exactly.
nighttime?
So the
I
explanation.
will explain this to you.
The sun is the great agitator. The sun is the great
I have
agitator.
just something to say
Remember
to
that?
Tony there very quickly.
Tony.
1 second, George. 1 second. Tony, you had something in your back garden. Marconi had a 500-foot long lead connected to a 500-foot long antenna. So he had 1,000 foot up.
Yeah.
So the chances of him getting a Morse code for the letter S was very, very strong. Do you know what I mean? What George
hear how this
and he got that during the day. Hang on, George. And then when people didn't believe him, he went out on a naval ship, and he got 700 plus miles during the day,
right.
and he got well over his limit that he had got before that I believe he did get, because I don't believe he had any reason to lie in the night time.
So I agree, and that's what I said about the ships, and I think it'd be useful if Anthony looked into that, because Marconi definitely did get those signals later on. I'm just a little bit suspect about whether he did that original one, and I know you believe it. I'm more suspect.
Let me just close this point off before we hand over to George. Let me just close this point off. If it was Rowbotham that did that transatlantic transmission, right, you would have a very different view on this. Your interpretation would be very different. And I suspect that you're allowing a very convenient adjustment mathematically.
Oh, no, Anthony, I'm saying
to excuse the obvious reality that can't be a sphere.
Hang on, Anthony, you're being unfair, right? I am the one who is saying that I don't think that Marconi's original detection of the letter S, I think it didn't happen on that day when he said it did between whatever it was 2:30 in the afternoon that he wrote in his notebook. I don't think he got that original signal. I think he did get the subsequent ones that Brian has mentioned, right? Because I've read about it.
It's an irrelevant point if you agree that the transmission eventually did or did take place. It doesn't matter whether he got it originally or not.
Saying if it was Rowbotham, I would be thinking the other thing, and I wouldn't, right?
If it was Rowbotham, you would have a totally different perception.
Hey, Riley, you just missed before you just came in. He pretty much admitted that, the Earth is not a sphere. What was the name of the story as well from the Second World War, Tony?
I didn't admit it wasn't a sphere. I was talking that you guys could look at something called Nickelbine beams. Yeah?
The Nickelbine beams, but the most reasonable and rational explanation is that the Earth is flat, right? There's no curvature, and this would allow perfectly for reality.
As you know, I'm interested in anomalies. The Nickelbine beams are an anomaly. Yeah, they don't have a, for me, satisfactory explanation. But
that's bollocks. Like, you're taking the piss in one sense. So now you go along and investigate the rest of the evidence for flat Earth that we all see, and you apparently don't. Well, we have to spend time convincing you or tiptoeing around in some sense, and let George here go through his stuff. Let me just say to Brian, I'll shut up then. Brian, so here's the whole point about coming to flat Earth, right? We want to discern what is happening in reality. The fact that there's these variances during daytime and nighttime will tell us something about the greater system. The biggest question that we have to answer is, what is the sun? And well, that's for a different conversation.
I agree, Pete. That what I would feel that the mainstream reason for that. I couldn't trust it because there's too many things that have been proven to be untrustworthy. Right. So I have to believe that we are not being told the truth of what people like NASA do know. NASA are not a fraud. They're liars, but they're not a fraud. If you know what I mean.
I bet you the ionosphere will turn out to be in or around 60 miles up, 60, 70 miles up, something like that. Would it be right, George?
You know it is, Pete. You know it is. You looked it up. There's no guess, Pete. You knew it.
I'm asking George here.
Are you ready?
Off you go, George. The floor is yours. On this chit chat.
This is how the physics of the ionosphere works.
Keep it compressed enough.
Here you have the surface of the Earth. You have a transmitting antenna. Now, there's two waves that get emitted from a transmitting antenna. You have a thing called the ground wave that hugs the surface of the Earth on tropospheric propagation. And then you have a thing called the sky wave that propagates from an antenna, and it goes upward towards the ionosphere. Now, the ionosphere can develop several layers called the D, E, F1, and the F2. Now, when the sun is shining during the day, the D and the E layers form, and they're very close to the Earth. And what happens is the sky wave will hit the D layer and come down. This is a very short propagation distance. This is no more than 100 miles. You can't get more than 100 miles on a D-layer propagation. This forms during the daytime, and it acts as a barrier for radio waves during the day. This is why you don't hear AM signals long distance during the day, because the D and the E layers are present that prevent the signal from going up high enough to reflect off the higher layers.
Layers of what, George?
At nighttime.
Layers of what, George?
Shut up. At nighttime.
I won't shut up. Layers of what, George?
At nighttime, without the sun shining, the D and the E layers disappear. So the sky wave goes up much higher into the F1 and F2 and gets bounced down. This is why in the AM band, around 1,000 or a megahertz, 1,000 kilohertz, you get long distance signals at nighttime. All of a sudden, the AM band opens up, is because the D and the E layers have disappeared, and the signal can go up much higher and bounce down, and you can get communication on the order of thousands of miles. Now, with RF signals,
George, I have to ask you a question there. 1 second.
Usable
George?
frequency.
George,
Now,
I have to ask you a question.
No,
Hello?
just let me continue.
George?
What happens with the signals? They go
George,
up
1 second.
and
This is
refracted. This is like index of refraction.
Prime.
He doesn't want to hear questions from me. He does not like me. George,
No, I didn't have him
is
here.
there a
He didn't
heavier
bother.
atmosphere in the daytime or the nighttime? Is there more hot air at high levels in the daytime or the nighttime?
Now, the thing is
there more hot air rising
Ryan,
in the
I'll
daytime
answer
or the
your
night?
question once I finish. Give me 5 minutes. Once you have a thing called the maximum usable frequency. This tends to be on the order of 30 megahertz, but can go up as high as 150 to 200 megahertz, depending upon the sunspot activity and how many ions come in from the sun and intensify this layer. But typically, it tends to be around 30 megahertz. What happens above
What is
30
the layer
megahertz,
composed of, George?
the signal
That's
can
what I'm
no
asking.
longer be refracted back down. It escapes through the ionosphere, never to be seen again. This is why you never pick up cell signals or frequencies on the order of a gigahertz, because the ionosphere never gets intense enough to refract the signals of that frequency back down. Anything above about 150 to 200 megahertz never ever gets refracted back down from the ionosphere. It's too high of a frequency, and it just escapes through the ionosphere into space. Now, the F1, F2
He was
layers.
fucking working on the other problem that Brian gave him anyway. You should be working on that, George. This is chit chat time. You got the chance to talk for 2 hours uninterrupted. I wouldn't have you here at all because I know you're a liar, right? But when I asked you what is the D layer composed of, you could have just stopped and said, well, this is what it's composed of.
Have a good night.
Off you go, bud.
This is what he does, Pete. He just wants to head off. As soon as you asking him any questions, you know.
Can I just give an alternative explanation for what George was just describing? When he was describing about the different layers, when the sun is out, it increases the evaporation rate. And when the water's evaporating, water vapor is less dense than the air that it sits in. So the water vapor rises. If you're trying to fire a radio signal through the less dense layer of water vapor, it's going to refract that light, because basically radio signals are part of the light frequency. It's going to bend that light up and out of the way the signal, the repeater or the antenna that's trying to
Riley,
receive.
that's a bunch of bullshit.
It's water everywhere.
Radio frequency. You know what frequency light is at? It's up into the hundreds of terahertz range.
All right, so
6 orders of magnitude more than your RF signals. It behaves
so you're saying
totally
that
different.
you're saying
How
that
things behave in ionospheres and plasmas and stuff in water depends on.
Are you saying that light?
This guy is just shouting everybody down.
Just
do that if I was sitting next to
just
you.
need to take control here for a minute.
With water vapor in the air that you get from ions. That's just
Thanks for your contribution, George. Go back to working on the problem that Brian gave me.
Calm down, one at a time, please.
What George is saying is that refraction.
What do you do when you know you're dealing with liars, right?
But it absolutely applies to optical observations, and it always conforms to a very flat-looking plane, right?
Exactly, Anthony. Yeah, exactly.
But what is the ionosphere composed of? The question I asked him. Right?
I'll ask him in a minute, Pete.
Down to density and buoyancy, and RF propagation using TEM waves is totally out of your pay grade.
Okay,
is it
hang on.
RF signals, are they light, George? Are they part of the light spectrum?
So what?
It comes back to what light actually is and what the sun actually is again.
Light is.
We notice drastically different
is
conditions when the
radiation.
sun is there and when the sun isn't there. Look outside your window and look at the dew falling. Where's all that dew coming from?
Radiation,
George, you don't have to keep talking. Shut your mouth.
Signal that you use for
You
communication.
spoke for the last fucking 2 hours. That's more time than you should be given.
Much higher
Anywhere.
frequency.
Okay, hold on, Pete. George.
It's true though.
Those two layers.
Doctor won't shut up.
Just one
This
thing.
is his tactic.
Hold-
They're the rumpus. They'll keep talking until they're heard.
Just one thing.
Well, you
I
get
want
rid
to.
of Pete.
Pete,
Pete's always disruptive.
right. Listen. Could you tell me what are those two first layers comprised of during the day? That was a question that
Which
Pete.
layers?
That you had 4 layers that you rubbed 2 of them off.
Yeah, the D and E. It's all layers are comprised of ions that the air gets broken apart by UV electromagnetic radiation from the sun. It breaks molecules apart and creates ions.
So you're saying
Ions of what? Ions of what, George?
So what?
Ions of what?
Air molecules.
Which air is composed of many different things, right?
That's why it's called the ionosphere, Pete. Yeah, it's called the ionosphere because it's the ions there.
So what has it settling at the points it settles at, George, under these different conditions, daytime and nighttime? You said the ions initially came from the sun. Is that correct?
Not the ions.
Anthony,
the
a
radiation.
question, if it's possible. Is Anthony still there? Anthony?
Yeah, I'm still here.
Yeah, off you go.
Would you say that during the daytime that there would be a lot more visual, let's just say, anomalies like mirages and stuff like that due to light?
Absolutely. During the night time, that's when me and Ranty got our best observations done at night time because we knew the thing we were looking at was lit up and we could see it like a Christmas tree. So during the day you got all the obstruction that they call curvature.
Do you get those distortions and that mirroring and all that kind of stuff? Do you actually get it at night at all when you do those?
a very small
long
amount.
distance?
A very small
Okay.
amount.
But you do get it. It does exist a bit, yeah, but not a lot.
You know, the thing that
one
guys
second,
are
George. I'm asking
you
Anthony
can't
something.
apply
So, Anthony, in your
everything
opinion,
that
Someone's
happens
talking, George.
phenomenons
1 second,
that
George. I'm
occur
talking to
He's a
Anthony.
bollocks, isn't he, Brian? He's a bollocks, honestly.
He doesn't want me to say this.
necessarily applicable.
Right. Whilst these guys argue, they don't realise that I'm not actually presenting them. George is just talking away right now, so we'll wait for it all to calm down.
Different characteristics.
Anthony,
I can
in
hear
your
you.
opinion, Anthony, in your opinion, then would the fact that radio waves and microwaves are part of the light spectrum, would they have a better chance of reaching their destination in the nighttime or the daytime, considering the effect? Yeah, considering the effect that the sun would and the daytime would have on light. Yeah, I would be the same.
Sun is the great agitator. It comes
Great
along
radius.
and blasts everything in its pathway.
It's still part, like you say, it's still part of the light sphere.
All you guys are doing is
Light
guessing.
follows.
I suggest you brush up, get an ARRL handbook for hams
Only if it's
and
speaking.
study about RF propagation in the ionosphere. That'll help you a lot. It's
Brian,
very
Brian,
well written.
the
It'll
point
help
is
you
here, George will
understand
bring us
what's
back
going
to
on.
a
All
93
you're
million
doing
mile
is
away
guessing. You're
falling.
taking stabs in the dark. You're
You know where he's going to
pulling
bring us
stuff out of
back.
your
When we
behind.
come to a flat
You have
Earth
no idea what
consideration.
it is you're
Shut
talking
up,
about.
George.
I think the
You hear
ionosphere
everything.
correction.
We'll come to flat Earth
Interesting topic that
consideration.
I introduced, wasn't it?
More on-
I've got a few more
When we come to
topics.
flat Earth considerations, we got to look at the sun and the whole system in a completely different sense. And this is where George, you see the way he's behaving here. Fucking 70-year-old man. Ridiculous. He has all the answers. He's dying to get in.
7-year-old child.
He's talking all
Of course
evening.
I have the
He's
answers,
been going through the
Pete.
same
I'm an
spiel
expert in
for 4 years
electromagnetics.
now.
I've spent 40 years working in this field.
Yeah, you
Who
might
gives
have
a
all the
fuck, man?
answers,
If
but
I
you've
ask
got
you about
people-
9/11, you'll parrot an official story. Every conspiracy I ask you about, you'll lie to me
No
about.
evidence.
You're a liar, man. So get
Yes.
back to Brian's
Well,
problem,
Randy,
George. Hang on,
you know,
please.
as
Hang on,
long
please.
as
Get back to
Pete
Brian's
is in
problem,
here,
George. And then when you have something to say about that, we don't want to be most interested.
Here, Pete is always very disruptive.
Right,
So.
get back to Brian's
Anyway, have a
problem
good
and
night,
then come
guys.
back
I'll
with the
catch you
truth.
later.
Because you're an
Bye.
honourable man.
Okay,
Off
Pete.
you go.
I corrected those. I corrected those things on my the London to Lagos. I corrected them, so they're much more. It's much more concrete in our favour now than it was. So thank you, Sleepy London. Sorry, thank you, Saucy London.
So, would you want to hear something a little bit spooky before we move up the ionosphere? Just quickly, yeah. there's these rumours that apparently people pick up signals from Second World War pilots who are long dead. In fact, there was a woman who was on a flight, flying, I can't remember, probably in about the 50s, and actually heard her husband talking over the radio, supposedly, because apparently there's this, sort of, I suppose, myth or urban legend that a lot of those signals are still actually bouncing around up there. Now, I suspect that scientifically that probably isn't possible, but it's an interesting thing. There's been a few recorded cases of it as well. I suspect it may be misidentification of other people talking or whatever, but it's an interesting thing.
There's something withholding. There's a container there. That's flat Earth is a great container. Now, why don't you, Anthony, particularly, can I ask you that? Why don't you consider the nature of the container and its possible effects on everything that's going on beneath? And also, if we agree that there is a container, as flat earthers, right, in that vague sense, then we have to decide what it's containing against. These are vital for consideration.
I'd like to hear what Anthony had to say there about what Tony said.
It's pure speculation, but with regards to Tony's point, I view that that hearsay evidence, that discussion thing about things bouncing around continuously or whatever, I view that as the equally as the ridiculous as the ionosphere explanation, in the sense that you guys absolutely need to have some explanation to calculate and adjust for why it is possible that you can ping something across the Atlantic. It's like you need an adjustment, so we'll just invent some at the ionosphere in the same way that some woman hears her husband bouncing around the ionosphere. It's complete garbage.
So how do you account for the fact, though? So fine, you regard them both the same. It's just an interesting fact. How do you account for the fact, though, that in my own practical experience, and many, many other people, but I'm talking about my own here because it could be hearsay from other people, that I'm able to communicate with Russia at a certain time of day?
Because the Earth's flat.
The same reason why me and Ranty...
Why wouldn't I be able to do it the whole time?
You have a phone.
Totally. Why wouldn't I be able to do it the whole time of day, all the time? Sorry.
Tony, let me answer. The same reason why me and Ranty could see Blackpool Tower crystal clear at night time, but during the daytime you got this massive layer of fuzz on the horizon that you guys think is where the sky meets the ground.
What is that fuzz? Water particulation, right?
It's something
the water in the air. There's no separating the water from a cubic meter in front of you. There's no separating the water from the air. So it is a water particulation. This is how we fucking see through the water. Water's reflected.
It's coincidental that me and Ranty are able to get observations done at night time over such a big distance of a small tower. And it's comparable with the explanation that is, well, you can't have AM waves during the daytime because blah blah blah. Well, at night time you get the AM waves. What is it only spherical during the day, but at night time it flattens off? Come on, light doesn't bend.
I'd like to add that I have yet to hear a plausible explanation as to how they were able to use microwaves to connect to the moon, and then somehow on the moon have enough power to send back signals and have a continuous signal, not broken up, continuous. They even spoke with the White House, supposedly. Yet those signals didn't bounce off the ionosphere.
Well, they're going, so a couple of things, that's easy to explain. They're going at a completely different angle, right? The ionosphere is because we're going at like a glancing angle, if you imagine it like a layer as George drew it. And obviously the signal from the moon is going down directly. And I think they had pretty clear skies.
Yeah,
hang on, let me complete.
Hang
on. Please, Brian, let me complete. You like to hear it. I like to give you a chance. Let me have my chance.
Okay, sorry.
Yeah. So there was in Australia like a 60-meter wide receiving dish that they picked those signals up from. That was certainly one of them. I don't know all the different Apollo ones, but the one I looked at, where I looked at the amount of power that they needed. So they have a relatively small transmitter, but they have a very, very big receiver. And the wave is coming directly down, and I think it was pretty clear skies, no clouds or so forth around, though I don't know whether it would necessarily affect those microwaves.
Yeah, but how did they get the microwaves out in the first place? Because every other microwave bounces off the ionosphere in the explanation that mainstream give us. So how come those particular ones didn't? And they're the ones that go to the supposed ISS and things like that. These signals don't bounce off this supposed ionosphere. They supposedly go in and out free flow. Yet they're no different. I looked into it. They're no different. They're no different.
I can just go and look it up.
It's a very ethereal thing, isn't it?
I'll just go and look up what the transmission frequency was.
We're trying to imagine, Brian, some sort of solidity that's bouncing off of. We're trying to imagine a big bunch of charged particles that have sort of varying characteristics during the day and the nighttime. But it's very vague, isn't it? And it leads to more questions and answers, I think.
Yeah, well, I mean, people have to remember that the Earth is rotating in that model, and so is the Moon, and at 240,000 miles apart. So how are you going to keep a constant signal there?
Well, let
Right,
me.
well,
Can I
look-
just say something here, guys? I'm presenting
Yeah,
something. I'm presenting something on the show, so you'll probably see it if you look at that. And essentially, this is an observation across water at night time, when essentially all the lights at the bottom, the Ferris wheel, everything that you're looking at, you shouldn't really see, except for the tower. The tower you should see, but everything below that should be hidden to Earth curve, right? So this is what we're saying. In the daytime, we don't get to see this. We get mirages, and at night time, we just get to see everything, including a concert that was playing in front of Blackpool Tower.
It's the water that reflects,
Ranty.
Ranty.
Ferris wheel, is that Earth curve?
But Ranty, you've been sort of rejecting the idea it's the water itself that is the main factor in the reflections that are going on to cause all of these distortions and obstructions. And it actually is, right? It literally is. If you're going to say it's the air in the water, or sorry, it's the water in the air, well, the bigger factor is going to be the water itself, because the water in the air is reflective just as the water itself is reflective. So
Yeah, but the bigger issue is the vapor in the air, because the vapor is less dense than the air around it, and that's why it rises. If you're going to try and fire a beam of light through that, if Snell's law applies one way, guess what, guys? It also applies the other way, and the sun is creating water vapor during the day.
So a couple of quick corrections. Yeah, we're not firing a beam of light. We're firing electromagnetic radiation through it at a certain
It's
frequency.
still part of the light spectrum, though.
Hang on, at a certain frequency. So it's not light, it's electromagnetic radiation. First part.
Yeah, it's still part of the frequency of light.
So, well, it's part of the frequency of electromagnetic radiation, which goes all the way. I can't remember at the bottom. It's like.
if you were to point that along the ground, Toad,
tell me
sorry
that
for
light-
But
interrupting.
hang on. The second point that was directly to Brian's, then we can go back to the electromagnetic frequency. We can bring it up or Google it, which would be a good idea, so we can all have a look at it and remind ourselves about it. But here, if you look, it's down at 2.2 gigahertz, which is above the frequency that reflects on the ionosphere. Yeah.
Right, let
And
me
they're
just address that
megahertz.
first.
Yeah, and the radio frequencies that they were using that I was talking about, the Nicobines, were I think 21 megahertz, which would explain, I suppose, that they could bounce off the ionosphere, though it still doesn't necessarily satisfy.
Let me just deal with that first point, Toady. If you're really arguing that the light doesn't bend in the radio transmissions, but it does bend optically, I don't know how you can not perceive that to be totally and utterly disingenuous, because light is
go
going to
slowly.
bend.
Yeah, go slowly. What am I claiming or not claiming? What are you telling me I'm strawmanning?
Your first
So-
point is that radio waves are basically, you said that they were a kind of electromagnetic radiation, right?
Well, they
and
are.
you
They're
indicate
part of the electromagnetic frequency, aren't they?
Yes,
We know
but-
that, don't we?
Yes, but the point is that you indicated that they don't suffer with refraction the same way that the rest of the light does that we see. And you guys tell us that we're looking around the curvature of the Earth with refraction, but apparently it doesn't apply to radio waves because they're... What is your explanation?
So we'll go slowly. Okay, here's the electromagnetic spectrum.
No, answer my question. The question that I'm asking is, why does refraction affect optical observations of light, but it doesn't affect the longer radio waves that longer than infrared light?
So we'll go slowly. Yeah, okay. We've got all the way through the electromagnetic spectrum. It affects light, yeah, in terms of light can be distorted. You can apply Snell's law and various other things to light waves. That's different to radio waves, and also, again, I believe, different to
So can you show me
microwaves.
where the science is that draws the line between the bits that is affected by refraction and the bits that are not affected by refraction?
Refraction from what? You mean light refraction?
Yeah, because that's a spectrum of go back to the top there, top of the page. Now let's just, I don't want to, the electromagnetic
Right,
spectrum
I'll
that
move
you've got
this. It seems
listed
to
on the
be
right hand
popping in
side.
there. Hang on.
What you're telling us is that there is some science that allows part of it to be refracted around the curve of the Earth, but the other part doesn't because it's the radio wave. So
hang
where's
on,
the science?
Hang on. Let's go slowly. I'll give you some science, right? I've got a little bit of experience here, right, with gamma rays, alpha rays, and beta waves, right? These are particles that come from radioactive decay, all right? Now, I have some radium that I've got from some watch hands, which glows in the dark, okay? And it also emits visible light in that spectrum, but it also emits gamma and alpha and beta particles, all right? They go through things. They go straight, as far as I know, and they don't, bend or refract, or I've certainly not seen them bended or refracted. They may in certain conditions, certainly not in the ones I've put them under. They'll go through a sheet of lead, some gamma rays, okay? So, you
So what
can't
you're
treat
saying,
the whole
is What you're saying is the gamma and the X-rays, they don't refract as per the rest of the light does, but the rest of them do. Is that what you're saying?
No, I'm just starting from the top with my knowledge of these different things, right? So these ones definitely don't. They seem to go straight from what I've seen. Don't know about alpha particles. They're bounced off like bits of paper, and beta, I think you
So you're
bounce
plucking this out
particularly.
your arse then, really, aren't you? You don't have
I'm
science.
wider for this conversation.
I have something to add to that.
Shit,
If you don't
Simon.
mind.
This is total conjecture based on your opinions.
No, it's not at all. Would you like me to go and
So can we
research?
have some science that demonstrates that X-rays and gamma rays don't refract in the atmosphere, but the rest of the light does?
But you want me to just produce some science now while I'm on a show
you're making
about
claims.
something
You're making
that I'm
claims.
not prepared for? I'm
No,
talking
you're making
about
claims, though. You're
science.
saying that some of the light
Fancy,
refracts, but the rest
fancy.
of the light doesn't, and I'm saying that's complete horseshit.
It's getting nowhere anyway. It's a pointless
I would like
conversation, and it's a chit chat. You don't need to go to Google as well.
Well,
Right?
exactly.
Just have
But
a chat
Anthony's
off the
getting
top of her head.
excited as usual. I'm talking about things that are within my direct experience because that's what I like to
Yeah,
do.
but
If you took that, let me ask this question.
It's your opinion, right? And everybody's got
Hang on,
No, it
right?
isn't my
Tony,
opinion.
let me ask you this
Not my
question.
opinion.
That gun that you point
I've
up and
measured
bounce
gamma
off the hang on, please. That you point up and you shoot and you receive a signal off the ionosphere. If you were to point that same gun horizontally at some screen or target, what's the minimum type of screen you would need for a reflective signal? Just to give me, I've sort of been asking from the start, what's the nature of these layers of the ionosphere that George was talking about? Can you give me
So
an
what are we
answer
talking
to
about
the
now?
question?
Sorry, let's go slightly. What are we doing now? We're pointing what at what?
That gun that you're pointing up and receiving a signal off of the reflection off the ionosphere. If you were to point it horizontally earthbound, what manner of a screen would you need to use in order to get a reflection or a reception back?
Oh, you mean bouncing something off something on the Earth? I don't know. Haven't got a clue. Not something that's in my.
So in other words,
realm of
what's the
experience.
makeup of the ionosphere? What exactly are the waves bouncing off of or not bouncing off of,
I
going
don't know.
through
We could all go and further read about it and explore it, which I think is.
So
probably
that's
a good
all we'll
idea.
ever get. That's what I'm saying. It's a waste of time talking about this shit.
Okay.
As I say,
All right.
we have
One
to
second.
apply.
Cheers.
But let me
right.
just say as well,
Fair dues.
we always learn
Fair dues.
something from somewhere.
I'll leave it.
I've
When
been
I've
talking
got
about an
some info-
energized barrier above, right?
Fine.
It's
When I've got some info, I'll come
hang
back.
on, please. I've been talking about an energized barrier above. The ionosphere sort of fits it perfectly. You need some sort of solidity, in some sense, for something to reflect off of. That's the bottom line.
I'd just like to throw in there what Anthony was talking about. Some while back, I looked into it. That fishing boats, and I'm not talking about big fishing boats, I'm talking about recreational fishing boats that can be anywhere from 16 foot to 24 foot long, use microwave transmission across the water. And okay, across the water will have a lot of atmosphere because it's the water, and especially if it's sunny and warm, it will have. But they're like, you can buy a 24 mile one, a 48 mile one, and a 76 mile one, or whatever. And people are opting for the bigger mileage ones that they can get receivers and senders for their boats that they have up on masts above their boats, because basically they have a lag as well. They have problems getting the signal out there, and there's a lag in the signal often getting back. They have a lag in the signal getting there, sometimes the signal getting there, and a problem with the signal getting back. And that's only across the water at like 40, around an average of 40 miles and less. You know, even though we're talking 16 to 25 miles, they have a problem that they sometimes can have a lag of getting the signal to them, and also on the other side a lag of their signal getting to the other boat.
We've seen footage from high altitude balloons, Brian, and I didn't see any sign of any ionosphere. When does it manifest? What's been reflected off what here? This is the whole point here.
I don't believe it at all, Pete. But I mean, I understand Tony would be probably more of the belief of it, and definitely George. I can't speak for them, but
you know the answers you got from George, Brian.
Yeah, well, George,
same from Tony.
Well, I personally would have no belief in it myself, being there, because it happened to turn up. It's kind of like the Bermuda Triangle. That turned up, the ionosphere turned up as soon as Marconi started getting a signal across that far. Suddenly the ionosphere turned up. There was no mention whatsoever about the fact that we have more heavy atmosphere, more warm air rising, more chance for light refraction, right, and different things like that during the day than the nighttime. There was never in all these years not one mention of that by mainstream science. And the Bermuda Triangle, that turned up literally at the same time as when they needed somewhere to start putting things that were supposedly shot off into space. And what planes ever went down there? Military stuff. Military planes went down there. There's the odd supposed story on Discovery Channel of somebody
who flew into
a vortex. No, this kind of nonsense.
It's all theater.
Yeah, it does not. What's in the Bermuda Triangle is probably bits and pieces of stuff to do more with NASA and different things. And things you can hide something there. People think, like, if I went into the Bermuda Triangle and I disappeared, and I could disappear because the military take me out, right? They sink me boat, whatever. I mean, at any point, it could be said, the Bermuda Triangle is a strange place. I'm going to go missing there.
Attach any type of myth to you, right?
Yes, exactly.
I think you wouldn't even be killed, Brian. You'd just be paid off, like, and you'd have a good life somewhere else, just incognito somewhere.
That's the way it works, why not kill me? Like, I mean, like, they'll kill me or you if we're in the way. Just because
I wouldn't say so. I said let you in a secret, Brian. There's a whole lot of theater going on here. What's his name was talking about World War II earlier on. Toady. I was going to try to jump in and talk about the hoax London bombing. So much hoaxery attached to everything that's presented to us in terms of history. That what is Earth? Where do we find ourselves? Are the bigger question.
I'll be honest with you, Peter. I'll be totally honest with you. I don't like getting into what I would consider. Now, a lot of people might take offense to this, but I would consider those kind of things the small issues. It's like all those things are a pure consequence of living within a lie. So we're constantly being manipulated by the same people who are keeping us stuck in the same lie. So deal with the big lie. Deal with the main problem. Never mind the small things. We're told lies every day when the news come. It's the lies at 6 o'clock and the lies at 9 o'clock every day. The lies at 1 o'clock.
You know it, Brian.
That's all it is. So
no, you know it, Brian. But like, there's different layers as well. I've been a flat earth just about 2013. So there's many different sort of stages of inquiry. And
I don't think so. No, I don't think so, because I don't think that. I think it's an ongoing thing. Whatever they do. I don't think it's just. It might have started back in 2013, 14, maybe on the internet somewhere. But as far as I'm concerned, that it is the big one. I want
absolutely,
cut the head off the snake. Stick the cutting the head off the snake. Forget about stabbing the snake.
But listen, look at what we're doing now, Brian. Look at what we're doing now. We're entertaining the likes of George Hatnock here and Toady. These people are known to are playing a part. They're lying. They're playing some sort of a deceptive role. So by us doing the same thing over and over again, where is that getting? All I'm saying is for people who are stood firmly on flat Earth, there's a greater nature to our reality. And sure, we can talk about all that stuff, Brian. You're king of Era, my friend. I shake your hand as that. Like, there's the highest authority on the land here that we've been tricked into, etc. But there's a different reality. And in order to realize one, we have to sort of be able to appreciate the other. So I think both are connected. But time and a place as well.
Pete, I appreciate what you're saying to me, and the same back to you, and I understand your concerns. But the point I'm making is that, I'll be honest with you, I don't care who's playing a part and who really believes or whatever. It doesn't matter to me, because I'm driven and I'm determined to make it the rest of my life, if I have to dedicate it towards making sure the whole Earth knows exactly what it is, right, and what it is not. And that's where. So, and there's so many other people like me and like yourself who don't want that more to do with lies. Now, if I'm concentrated on who might be a plant, who might be CIA, whatever, I don't care who they are. I just don't care. I'm looking straight past and straight through them every day. They don't matter to me. And I'll deal with them today, and tomorrow I'll deal with someone real. It doesn't matter to me who they are, because if I'm focused on them, sorry, go on.
Right, no, I'm bored with this conversation. Let me get it back onto the somewhat on topic. Do you agree with me that the ionosphere's creation was simply an adjustment for the fact that Marconi was able to transmit a ping data right across the Atlantic? Absolutely,
I do. Absolutely. I would have said that to Tony myself, except for at the time I was doing calculations on my phone. That's all. But I absolutely. There's no other explanation for it.
Well,
And
let me jump
secondly-
in and say there's suspicion.
hang on.
Let me tell you, there's a suspicion attached to the whole Marconi story as well, more fabricated history. But we can't forget Tesla, right? So if we're to take Tesla and all his realizations, as the story goes, Brian, and as you know, come to sort of mainstream prominence in the form of Elon Musk these days. Well, is there sort of a reflection of real reality being expressed in a different way? So I wouldn't rule out the ionosphere completely, but how does that fit into your thinking?
Let me just ask my second part to my question. Would you agree if you agree that the ionosphere was simply an adjustment or a calculation to explain this on a sphere? Would you agree with me if I was to suggest that if any baller just accepts that as the explanation, they will believe literally anything if it's corrected with a little bit of maths?
I would, absolutely, yeah.
That's what's happened.
Yeah. Well,
that's what's happened for everyone in chat on our side, on the FE side. They will believe anything if it's corrected with a little bit of maths, and we're like, maths isn't the proof. The fact is that we can do this. Just imagine if it was Rowbotham that did that Marconi test, and he come back and he said, "Look, the Earth's flat." You'd have somebody else that repeats it, right? And then there'd be a bet between Wallace and Hampton, and they would have a fallout. And the guy that was basically saying there's no such thing as bendy light, he'd end up in jail, and you ballers will just believe it because it's all corrected with a bit of maths, and we're all sat here shaking our heads thinking, how the hell can you just accept this as a little bit of maths? It's rubbish.
I totally agree, Anthony. It's like, if you're going to believe that, it means that you want to believe those kind of things.
Yeah.
Because, I mean,
it supports your narrative.
Yeah, well, what we talked about the daytime having a heavier atmosphere and having more light refraction and all these kind of things. I mean, that's a totally obvious answer that I heard never one thing about from mainstream science about that. They just went, the ionosphere, and went with it. You know, I mean, I asked Tony earlier about how they got the signal to the moon and then the signal back even harder again. He said, there was a big dish for the signal back and they just used a higher frequency. So where is the proof?
I remember me and Ranty doing the observations from Hoy Lake up to Blackpool Tower. And normally when they're like, it all depends on the visibility of the day. If the visibility is good, you see more. If the visibility is not good, or there's a bit of a mist on the horizon, you can't see shit because what we're looking at is tiny. But what I realized is that we see so much clearer at nighttime than we do during the day, because whatever that layer is, that refractive band or whatever you want to call it, I don't know what I call it dirty air. Whatever that is, that's basically, in my view, that's the effect of looking at the water vapor evaporating off the surface, bending the light away from the target, and you can't see the bottom of it because the light's being bent up, not because it's being bent down behind the curve. It's going through water vapor. It's less dense than the air it's in, so it has to bend the light up. And we see that with Dr. John D. Literally, his laser was curving up when he was doing his Bournemouth observation. That's really what we're looking at. But these ballers, I can't emphasize it enough. A little bit of maths, correct for it not being flat, and they'll accept it.
Well, look at it this way, right? This is going back to what you were saying about this radio wave over the Atlantic Ocean. If you remember the idea that we went to the moon and we put laser reflectors on there, so they needed the laser reflectors to be positioned just correct, to get this signal back, right? Now, if you're bouncing these radio waves off the ionosphere and they're hitting back to the sea and then back up to the ionosphere and back down again, repeating, you forget there's waves out in the Atlantic Ocean, and those waves, the average wave height in the Atlantic Ocean is around about 5 meters, a significant wave height, which is around about 17 feet, which means that when the radio waves bounce down to hit the wave, if they hit the wave on the backside of it, the signal is going to go backwards. It's not going to carry on. It's not a flat piece of land that can just go bounce up and down in a regular way. The nature of waves would force the wave to go back in a different direction.
Yeah, I mean, they've never proven that, especially with microwaves, that it will work in any other way other than line of sight. Never ever has it been proven.
Can't do line of sight, anything other than line of sight. If you try and line your satellite dish up to your satellite that you believe is orbiting the Earth, you only need to be a midgie stick off and you're not getting that signal. So when they say things like, oh yeah, you're bouncing a pulse of the radio wave off the thing and you're getting a pulse back that's like a pond ripple, you're not. Yeah. it's a line of sight. If you don't have it as a line of sight, you ain't getting shit, and that's why it can't be a sphere.
Yeah, but I don't understand why people don't realize that this supposed satellite is supposedly orbiting us. So when your dish is perfectly on it, it's only on it for a second in accordance with what they would say, and then the satellite is up and moving again. Unless your dish goes around in a 360-degree following the satellite all the way around, which they don't.
No, they explain that away with geosynchronous orbit, but the problem with geosynchronous orbit is what do they use as the point of reference to maintain their exact location in the sky when they haven't got any kind of grid reference above them or below them to be able to stay in that same position? They're relying on not moving because they only need to move a little tiny bit and you're not getting that line of sight.
Yeah. I mean, the reason that the dish is pointed up at the side of someone's house or the top of someone's house is because the mast is a lot higher than where that is. You know what I mean? It's such an obvious answer. Where are the radio masts? They're up high. They're in mountains and places like that. Go
I was thinking about that, Brian, just in terms of possibly just what you said there, and George mentioned it earlier on about the standard candles. Just in my own brain, Polaris could be 20 miles high, but because it's so bright or intense, it melds into the rest of the sky. We don't know what's going on in reality. But let me just say, in relation to all of the different matters that are been discussed here, and there'll be that constant division. How many times are we going to put the same arguments forward to the same heads, right, and expect a different return? This is what something retarded is going on someone's behalf. But in terms of the real nature of our reality, which is what we're all here for ultimately, Brian, I understand your point exactly, man. Just you probably don't understand. I was talking to George back in 2015, having these same arguments or something similar, and him doing the exact same thing. So there'll be that history involved as well, and that impatience. But fundamentally, the same thing is there. We all know the Earth isn't a spinning ball. So the only way we can focus our attention, not deal with the rest of it as well, but is what is. Because in order to find out what is, right, or that venture there, then we can sort of explain more certainly what isn't. And I think we can all relate to that.
Going back to what George presented before, when he said that the planes actually follow Coriolis, one of the people in chat sent me an email with a citation from something called skybrewery.aero. So it's some kind of PDF or something. Coriolis, as an aircraft travels from A to B around the globe, it actually will follow a curved path, or a series of shorter curved paths, as INS will detect this as turning, a bit like a pendulum swinging out in turn, and an error can be introduced. So essentially what it's saying here is that planes do curve. I don't believe that. I've yet to see the data for that, but it is a citation that backs George up, just saying.
They have to curve on a globe.
Exactly.
Do you know what I mean? They have to. That's the way they go.
The whole game is rigged. Yeah, they have an explanation for everything. Come on.
I think it was Kosho. I might be wrong. Somebody, Chocolate, will be able to correct me on who it was, but somebody said that circles are made up of lots and lots and lots of straight lines rather than a curve. And that's basically what you have to do in a plane. You have to do lots and lots of like micro curves, like continuously adjusting your angle, and it's nonsense.
Well,
you just mentioned the old squaring the circle problem, Anthony, in case you didn't realize. So to get a closer approximation to pi, the relationship between the diameter and the circle, they had to do exactly that. Smaller and smaller lines to make up the circle as a whole. So you didn't probably realize that. But
I just want to say, thanks to Saucy London and what he said earlier, thanks a lot, Saucy London, that actually, if the plane flying from London to Lagos, right, if that plane flew at average speed of 575 miles an hour, which is the average speed for that particular plane, right, then it would actually fly 809.095 miles more than it needs to fly. Yeah. So how can that be going off to the left, which is where it would have to go? As the globe says, it goes from west to east because the sun travels from east to west. So the globe would say it turns from west to east. So that would mean it would have to follow a much bigger angle off down to the left. But it's reaching the distance. If it went at an average speed, it would actually travel 809 miles more than it needs to go. So it's actually flying
Nonsense.
a lot slower than it needs to go just to get that distance.
It's indefensible at this stage. And the example, so that ties very much into what I asked George initially, Brian. So what it comes down to is I'm at the North Pole. I want to shoot at Mexico here, my missile. I'm going to have to point here towards Hawaii.
Yeah.
That's pretty much it. So I'm going to have to shoot in that direction.
What they didn't, what the lads were like, Tony was saying something about ballistic missiles and about he talked to someone who they have to do a lot of research to make them very precise. That's no. What Tony, it's not that he was telling lies. Tony is an honest fella. I don't think he was telling lies. But what he was not realising, what he didn't know, is that the reason for cruise missiles is because ballistic missiles aren't reliable for being specific. Ballistic missile, yes, you can make it specific for an area. Like if a ballistic missile was to shoot at Birmingham or shoot at Stockholm, it would land more or less in East Stockholm if it needed to. Right, but there's no guarantee it'll land on somebody's house. Whereas a cruise missile is line of sight, and they're designed to go up high first, travel at a cruising altitude, then come down low, then travel, especially if you're going for a ship, then travel only meters above the ocean at a tremendous rate. I'm talking about like 2 to 4,000 miles an hour, and hit the ship low. The idea is hit the ship low, take the ship out. There's no point in hitting the ship high. As well as that, you're underneath detection when you're around low. So that's how a cruise missile does. Now, a ballistic missile won't be able to do that. It'll only do it maybe by chance or by accident. Ballistic missiles go up in an arc and come down. That's what they do. A cruise missile doesn't. A cruise missile shoots up, has a high cruising altitude, so it can't be detected and can't be shot out of it, basically. So it's hard to intersect. Then it comes down low and hugs the sea or the land within meters, mostly the sea, to take out a ship. And that's what cruise missiles do. Right? That's why there's cruise missiles, and they work line of sight. They don't work any other way. And anyone who's trying to say they work any other way is absolutely lying to themselves. And they don't take Coriolis into account because it's a missile. If you look at what's in it, it's no different from what's in an airplane. The same stuff. And okay, it would be the top of the range navigation stuff, but it only has the same as an airplane has. You know, it has probably a fiber optic gyro and the altimeter, you know, the usual. Just on your point there, Pete, what you were saying. You were saying you were arguing with George back in 2013 or whatever, right? 15. Sorry, 2015. Yeah, I got into this in September, October 2015. I had seen it before that, but I intended on looking at it, but I didn't. It was only just a thing on the internet, a corner of the internet. But I will say is, yes, you might be having the similar arguments with the similar person now, but the audience that is being reached now is so much huger, and the flat-out arguments are so much better, and the whole argument has progressed so much that it is being shown to those who are watching that we are showing a much more realistic and down-to-earth science than the globe side is showing, and we're showing that they can provide the evidence that would be considered, let's say, solid evidence for a huge majority of the claims they have. So that is the thing. Yes, it's slow, but it doesn't matter. It's the audience we're hitting. And okay, we'd rather be dealing with professors, but they won't deal with us yet. They won't deal with us until they absolutely have to.
Yeah, well, it's fair. Look, that's why it's important in our everyday lives to try and talk to people on the ground. Pretty much everyone I've spoken to have at least heard about the flat Earth controversy, and everything is unraveling here according to plan, as far as I see it. There are many different layers here, Brian, but absolutely agree with you. There's no debate anymore. So I guess it's all about the format that is going to be presented to, as you say, the audience. When you have the likes of George here, you see he has a sort of a basic lack of respect in a certain sense. I hope he'll come back in and answer your question, but he's going to have great difficulty. But it's just because I've called him out as a liar many times before. Same with Toady here. So what are you supposed to do? I can put on a part for a certain, I don't like putting on any part, but I can sort of hold back. But after a certain point, then you realize you're getting nowhere. Whereas, for instance, we haven't talked before, and as flat earthers, definitely we have time for what is, as opposed to constantly just being stuck on what isn't. We can go anywhere in our minds. We have all the time in the world, in a sense. Maybe that's why we're here, is to work on everything. So a different conversation worth all of that.
The thing about it is that sorry, Peter, I didn't mean to cut in on the end of it there. What I would say about it is that with George is going to stay staunch in where he's at. I don't know what effect it would have on George to have to accept that the Earth is flat and not a globe. For him to have to accept that would be very difficult. Tony would roll with it way more easier. But Tony's a lot younger and he's a lot more open-minded. Even him saying the thing about the German beam connectors. I can't remember the exact words he used or the exact name of it, but I'll have to listen back to the show. But him talking about that, I mean, George will roll with it. Tony would roll with it a lot more, but it wouldn't be totally easy. But he would roll with it a lot more. But there's so many people out there like George who are not going to change. What's going to happen is that they're going to, no matter what evidence is presented to them by us, they're going to argue about it until someone who's higher up, who they see as a peer of theirs, eventually goes, hang on, this means something. Because there is actually people who are actually honest people, who are in science, who are high up in the universities and that. And they can't ignore their data forever. No. They can't. Not everyone is dishonest about it. But people like George doesn't care whether we're right or wrong. He doesn't want to hear about it. Even last night I had a thing with George and he got pretty, I'm not going to go into it, but he got very nasty with it. Anyway, all for nothing.
But Brian, look, there's a monstrous lie against all of us. And in order to carry the lie, people have to be put in place. If I said to you, for instance, and I hold this has to be true, right? The likes of George and Rumpus are probably on $100,000 a year for what they do. And they're associated with the monsters, if you want to put it like that, who are giving us all of these monstrous lies. It's not just one particular area, it's every aspect of our reality. So that would change your point of view, I guess, if you found out that was true, or at least you took it as a serious possibility. I hold that to be true. These people aren't giving up their time. These are well-educated, well-spoken people that in industry, they could make that money. They're not, George, as he admitted tonight, is getting no return. He couldn't name one person that he convinced, but yet he's happy enough with infinite patience to come back and give the same argument, as if he's not intelligent enough to consider the things that we consider. Let me just clarify, go back to the main points again. When I'm talking like this, I'm just talking for myself. I assume that people are genuine until I know better. And with people like that, I know better. So there's a different game. There's many different layers going on to the different types of questions that we can, and avenues we can go down on. So,
can I just say that tonight we cleared up an argument that's been long-standing actually in the flat Earth debate realm, which is does the Earth spin underneath the plane? And to all accounts and purposes, George, along with that citation that somebody sent me, said that it does. So I mean, it's been argued by many a person that it doesn't. It's in the same reference frame, etc. So there's a difference between powered flight versus a projectile. So the idea that George has come on and then set the record straight in his mind from what he believes, which is that the Earth turns underneath the plane, well, I'm sure that is going to open up a can of worms going forward, and a lot of investigation is going to follow from that. And this is what the formats are for. The formats are for the putting the tests of the claims of the Globers, as well as the flat earthers, bearing in mind, not just the Globers, but the flat earthers too, and holding the toes to the fire and checking out whether it works out. So going forward, I imagine over the next couple of months, people are going to test this idea. Is this actually what happens? And this is what we needed to hear. We needed someone to come on from the globe side to tell us that the Earth turns underneath the planes. Now that he has, we need to go out and check it out.
Yeah. Well, look, the London to Lagos flight completely disproves what he says. That's why he didn't want to address it. As soon as he heard that there was a discrepancy, he said, no, this thing is all messed up in 4 different ways. It wasn't. It was a discrepancy that I got off the airline originally. And I didn't mind because it actually, what Saucy London gave us actually totally helped us. It's way better now. Is Anthony still there? He's gone on mute.
Hopefully George will get back to you anyway, Brian, with a comprehensive answer. Remember, I held him to account. First of all, I said, are you an honest man? And will you give an honest appraisal? Will you be humble if you are wrong to admit that you were wrong? So hopefully we look forward to his answer on that, because it is a stickler. And if you go back and listen in more simplified terms to the example that I tried to give regarding firing a missile from the North Center to Mexico, well, his whole answer is full of ridicule, so it's very revealing in itself. We look forward to George's comprehensive answer on that. He's an honest man.
I'd like to hear more from Anthony as well, Pete. See what Anthony has to say there, because we get back onto a subject.
What was the question?
There wasn't any. I just wanted to see if you were still involved. That's all, because I thought you were after kind of trying to talk a couple of times.
It was more to do with the fact that George told us categorically this evening that the Earth does rotate underneath the plane. And the plane needs
the minute he says that means that flight's one way are much quicker than flight's the other way, and we know that that's not true. So, the thing is with the Coriolis, they need to have it both ways. They need to. That's why they'll obfuscate it to death. They need that plane to be in a fixed lockstep spinning atmosphere when it suits them, because we don't see planes flying faster one way than the other. But they then need to flip it and say, well, Coriolis, because if the atmosphere is in lockstep with the Earth turning, that means that there is no Coriolis by definition. You've got to have an inertial reference frame. You've got to have a non-inertial reference frame. Well, one of them's got to be stationary.
Well, let's just clarify what he said. Let's just clarify what he said. So, planes going east to west, they have a terminal velocity when they set off. So it doesn't account going east to west. But if you go from north to south, then you have to account for Coriolis. That's what his position was.
That's right, and I argued that against loads of ballers, that it was only north to south flights where the Coriolis would take effect, and they were all arguing it was east to west. And I'm like, no, east to west would just make it faster or slower, but there wouldn't be a deflection. But basically, this is another thing. I was listening to Blue Marble Science, that dork, arguing against the Coriolis force or the apparent force, and basically what he was saying was that it's an apparent force, but it's a real force. And I'm listening to him arguing it with who was it now? It was Chris Berry, and he doesn't understand what a non-inertial and an inertial reference frame is. And basically, I would challenge Blue Marble Science to debate it with Nathan. Nathan will just pull you. He would just eat the meat off the bone and spit out the bones afterwards, because Blue Marble Science doesn't know what he's talking about. You have to have a stationary reference frame, and you have to have a moving reference frame for Coriolis, but it doesn't apply to Earth. There is no deflection. The observer sees a straight line always. There is no deflection, so there is no Coriolis. It doesn't apply to Earth. Stop claiming Coriolis does, because it doesn't. So Coriolis is a force. It is an effect. We do observe it. We just don't see it in relation to the Earth.
Yeah. One other thing I'd say about what George was saying is he's saying when the plane is taking off, it's holding the same velocity as the Earth is basically, and the atmosphere is moving at that point. What about if it's taken off and going the opposite way from what the easy way is? What happens if it's going the opposite way, the hard way?
It says what I mean? He says it retains that. It retains the same terminal velocity. When it leaves the Earth, it's still going at the same speed as the Earth, plus whichever speed it actually is pushing through the atmosphere.
Yeah, well, if it's taken off on the equator and it's going to another place on the equator and it's going against the spin of the Earth, or it's going if it's going in so if the Earth is spinning west to east, as they say, west to east, and the plane is taken off in America and it's trying to get to the Europe, let's say, or the America down to South America and try to get over to Africa on the equator or whatever, right? Then it's going to have a hard time because the Earth is spinning faster than the plane can go. It doesn't work out. It's like once it lifts off, it can't be. How can it be brought with the Earth and still reach where it wants to go? It can't. Do you know what I mean?
Both ways. They've got to have it both ways.
It's absolute nonsense. And on top of that, is there what I wanted to ask George, and he disappeared. And I put it into the chat. I wrote it in chat earlier, but I should have wrote it in as a question. Is there any? I don't know. Maybe I did, but is there any meteorological data to support the atmosphere moving in lockstep with the Earth? Because there should be meteorological data to support that. considering they deal with the weather systems all the time. There should be support that there's always, that the atmosphere is always moving in one direction. Is it there?
I think meteorology is one of those things that's so abstract, unique. It's so unpredictable that you could kind of get evidence to support any assertion you wanted in meteorology because it's so unpredictable. They think they're not talking about what they don't.
Pete, are you still there? Well, he must be gone to someone. But yeah, well, I don't know. See, the thing about this is that there has to be some data. What is the data to support, the actual data to support that the atmosphere moves lockstep with the Earth? I asked George last night, and he did not like it. I said, is the atmosphere a force? And at first he said no. And then he had a little think about it, and he started, he said, why? And I said, well, how does it carry things with it? Then he started kind of avoiding things and having an argument about something. Then he came back to, what was the question again? I asked him, is the atmosphere a force again? He went, well, yes. But some things, it depends on an object's velocity vector, I think he said, whether it will be affected or not. Basically, going back to the bullet thing. And I said to him, like, oh, a bullet will show a Coriolis, but something with power won't. And I said, well, George, I said, is there a video anywhere of a glider? I said, someone flying a glider, taking video from north to south, taking video of the Earth spinning underneath him. And he said, well, if you look hard enough, then you probably might find one. I said, there should be thousands of the videos. I said, the only place we can see this supposed turn of the Earth is if we're able to sit on top of a bullet that's moving from a sniper's rifle or space videos. That was it.
Ranty, just present my screen a sec. One of the things that pisses me off about the argument on Coriolis is that they always bring up hurricanes, and they say, well, why are they always rotating one way in the north and one way in the south? And the reality is we can replicate this on a swimming pool that we know is flat, and if we can demonstrate vortexes that one spins one way, the other spins the other way, the sun is basically this plate. Are we on, Ranty?
I can see it, yeah. I can see it on Skype.
Yeah, Ranty, are you screen sharing for me?
It's on mute. I can see it on Skype. I don't know if it's seen out of the map.
Basically, all she does is she pushes the plate through the water and it creates two vortices. One's going one way, the other's going the other way. And it's essentially a hurricane on a flat plane, and it's caused by the sun, the paddle of the sun. And that's all. Yeah. We can demonstrate this. We don't have to have an explanation for why hurricanes don't work on a flat plane when we can demonstrate two vortices in the medium of water. And let's be honest, the atmosphere is treated as a fluid. We can demonstrate it on a flat plane. Hurricane's point is completely and utterly ridiculous. Stop
Absolutely.
Ballers.
Yeah, I've seen this before. And you know what it is? This is one of these things that you watch that video there. And when you see it, you go, yeah, every time you run a spoon or anything through water in a sink, you'd see the same effect. You know, if you have a full bathtub, you can see the same effect. You can see the same effect. And it was something we've all seen all our lives, but we never questioned it. We never thought about it. We never went, that looks like two hurricanes.
So if the sun is the plate, what does the water represent there?
The atmosphere, the fluid of the atmosphere, because the atmosphere is considered to be a fluid because it's a gas, and gas behaves like fluid. It conforms to fluid dynamics. So the atmosphere is the water.
We know this is a big problem, you see, because George will come back and give you a definitive answer as to what the sun is. As flat earthers, we know it has a vital role in everything. But what is the sun, Anthony? Or have you clarified anything regarding your own search? Because we know, as I said, we know these are fundamental components.
Whatever the sun is debatable, but what we can demonstrate is what it does. And we know that if you have a focal point of light on water, it is going to create a convection current. One goes one side of the light, the other goes the other side of the light. And by virtue of convection current, you are going to get a rotation. And that happens on a flat plane, the same as it happens on a sphere. And just because you get hurricanes going one way in the north and the other way in the south does not mean anything. But you morons all think it does.
Well, this is interesting. The sun leaves a wake, like you're driving along in the rain. And the wake your car leaves in the wet road, right? So Absolutely. They have no argument against any of the arguments at this stage, right? I haven't heard any satisfactory answer ever from any bowler, ever. You know what I mean? So if I was to continue on tomorrow expecting one, I'm not going to get it. I'm just fooling myself there. But when it comes to what it actually is, then we need to, I think, make progress somewhat. Again, in a different sense, regarding what these things may be or can be, and can we know any of these things now? I know there's a big deal between you and Bob from Globebusters, who did the impossible, by the way. He went back from 9/11 complete media and victim fakery hoax to the Judy Wood camp. But he's talking about the ether muchly these days, as is Theory Apophysia, what's his name, Ken Wheeler. So, I mean, have you considered the ether in any sense whatsoever, how it might play into? We talked about different conditions when the sun is and isn't there regarding ionospheric reflection. So have you thought about the ether? Have you considered what it might be?
I think it's totally like conjecture or opinion, because I don't really see what relevance the ether, whether it exists or whether it doesn't exist. I don't really see what relevance it has within the topic, because I don't think it's contentious in the sense of the shape of the Earth. It's just contentious within itself. Does the ether exist? Yes or no? Well, maybe it does, maybe it doesn't. But what relevance is it on the topic of like what shapes the Earth?
Well, absolute relevance in one sense, because if your child is going to school and is looking at Discovery documentaries, they have a lovely, neat picture of the Earth as is in the blue marble form. So if you're going to try and put across the truth to your child, how are you going to do it? What picture are you going to paint? You know, so it plays absolute significance when we think in the greater sense of our reason for being here, I should hope, which is to find out the nature of our reality. We know what isn't. What is? I mean, and you say, let me just say, you say, what relevance does it have? Well, I mean, maybe everything is interconnected. So by you thinking something has no relevance, it could turn out to have absolutely major relevance in terms of helping you piece together the greater picture.
Listen, I'm either or. It doesn't matter to me. If it exists, it exists. If it doesn't exist, it doesn't exist. I don't really see the relevance of it. But if it is relevant, I'll be corrected. It's fine.
Well, what I'd say about the ether is the ether was a kind of an outside, kind of the black sheep of science in a lot of ways, until flat Earth came along. Again, let's just say, because it didn't just come along all of a sudden in 2014. But the ether, then, people who believed in the ether were people who thought outside the realm of mainstream science. A lot of them became flat earthers, or at least looked into it. And so the whole thing about the ether existing kind of got lobbed in with the flat Earth. But it doesn't make the Earth not flat or anything else. I don't really know the full relevance of the ether. What actually is it supposed to be doing? I've never looked into it, I'll be honest. I don't really know what it's supposed to be doing, and whether it being there or not is going to change anything that we've already, let's just say, like for instance, relative density. How does ether connect to that? Does it connect in any way? Like,
might do, it might not.
Yeah, light, the behavior of light. It supposedly has some connection to that, but it seems to me like the people who believed in it were people who are already kind of the black sheep of science. And when flat Earth came along, it was like nearly a crutch, or not a crutch, sorry, a step to help them to step up a bit and say, look, the ether is probably there as well, and people who didn't believe in gravity and believed in the ether, this kind of thing. And so a lot of those kind of people have kind of been lobbed in with the flat Earth, but I don't know if it has any relevance. It's probably more real evidence-wise than gravity, because I can't find any for that. But, I mean, that's not saying much, let's be honest.
You can't find any evidence for gravity, Brian. There is evidence for gravity.
You can't even define it, let alone provide evidence.
Right, well, this is the point, but there is evidence for some sort of force that you talk about relative density being a satisfactory solution to everything, but you fail to consider the possible nature of the barrier, the container that you say does exist, Anthony, or you say that the considerations of what the sun may be in this new flat Earth enclosure has any bearing on the greater consideration.
Do you want me to start making assumptions?
least.
Do you want me to start making some assertions so that ballers can immediately ask me for some supporting evidence that I know that I haven't got, just to
Fuck the
satisfy
ballers,
you?
man. Fuck the ballers. This is a chit chat, isn't it? Amongst maybe flat earthers
Why would I make
for
assertions?
advancement of
I think the
further
sun is.
ideas. The
I
ball
don't
is
know.
already demolished.
I don't know what the sun is. I'm all right not knowing, because the most we've got is a P900 and a compass, right? What the hell do you expect us to be able to work out when we've got zero resources, personnel, equipment, tools, anything? We've got nothing.
You have your mind, right? Are you telling me you're not working on any private investigations?
Yeah, but Pete, I think that the point that Anthony's making, I was going to say something to you a while back about it when you were speaking about the sun to Anthony, was that I'd be able to say, it's like we're not in a position really to find out what the sun is. We can use our minds and use logic, and that'll bring us very far. But as far as actually tangibly finding out, it's going to be very difficult from our point of view, considering we don't have the funding, we don't have mainstream science to do that with.
Sure.
So, but what I would say is
we can have thoughts, though, Brian. We can have thoughts.
But we can all have thoughts, but we all have thoughts, and that's fine. And I have many thoughts, but I wouldn't put them out on the internet because, as Anthony says, he could be attacked by the other side by having these assertions.
I'd love to hear your thoughts on other things, Brian, but fuck them. The other side,
in a more private sense, yeah.
The other side will attack you no matter what. They'll attack your family, attack your character.
I'm just saying, not in the public,
no, that's grand. I know.
Yeah. They're not bad. They're just different from the mainstream, and it's the mainstream that are attacking us. So that we have to be careful about making assertions. But what I would say is that I think we should stick with what we can prove and the bare bones of the nature of where we are, what it isn't. Stick to proving what it isn't. And we keep proving what it isn't, what it is will become so much more clearer.
But prove it to who, man? Who are we proving it? You can see the censorship on YouTube itself here, and in terms of the mainstream as well. Now, this translates to the people on the ground as well, where you ridicule for even thinking in terms of flat Earth. So again, who is it proving to? You can be sure 50% of the audience in chat here are here for George, or on the Ethodian George side. So I mean, I get what you're saying, but again, there's time for other considerations. We're all on personal journeys here as well. And as this is more of a casual chit-chat sort of arrangement, I should think more than just the basic arguments. Remember, this is a day one argument, the Coriolis and planes flying east to west. Would you agree with that? Back in 2000, and it's the very first questions you meet when you enter
it is. It's one of the first things I came across as well.
Exactly.
One of the first things I came across as well. Like there's a load of things. There's the gas pressure. That's not new. I came across that back in October 2015. There's a load of things I actually came across back then that aren't even being spoken about now, and they're not bad things. They're good things. But
okay, guys, I think that'll do for this evening. If you enjoyed that, leave a like. The gentleman speaking now, you've got Pete Shea. I'm just going to link his channel right now, so if you enjoyed what he was talking to, head on over there. He has 606 subscribers right now. He's always putting little shows on. Also, I promised that I would give a shout out to Nathan Oakley. He's just 34 subscribers short of his 15,000 target. And if you want to subscribe there, there's his link in the chat too. So you have two channels there to perhaps click. The top one will be Pete Shea, and the bottom one will be Nathan Oakley, who hosts the Flat Earth debates. As I say, 34 subscribers short of his 15,000. So if you're not actually subscribed to any of these people and you like the content that they put out, I would appreciate it if you would just head on over and give them a subscribe. In the meantime, thank you very much for stopping by. We've been going now, it's 20 to 3 in the morning. I hope you enjoyed the presentation with George. It was nice to get some clarity on the Coriolis and what the belief of the globe is, and how we can perhaps look at this in a different light going forward. So that's all good. In the meantime, that'll be me now until Monday. I'm going to have tomorrow off, and I hope you have a great weekend, Sunday, and I'll see you all in the next one.